Yeah, hi there, and welcome back. And let us continue with our lesson. And today we are going to learn about the Kotlin flows, and it's really interesting topic. So before we jump into the coding part, let us get started and let us learn some of the basic concept about the Kotlin flows. And before you start the Kotlin flows, make sure you have a basic understanding about the Kotlin coroutines. Coroutines and a flow is goes together in hand to hand. So we must understand the Kotlin coroutines before we understand the flows. And if you don't have a basic concept about the Kotlin coroutines, then the flow will be really difficult for you to understand because it's making use of the Kotlin coroutines. And if you are not familiar and you don't know how to get started with the Kotlin coroutines, make sure you go and check my profile page. I have already a course on the Kotlin coroutines where you can learn about the Kotlin coroutines from basic to the advanced topic. So I hope you already guys have some understanding about the Kotlin coroutines. So let us get started over here. And in coroutines, a flow is a type that can emit multiple values sequentially. So here which you have to take note on value sequential. It's emitting a multiple value sequentially as opposed to a suspend function that returns only a single value. And if you are familiar with the Kotlin coroutines, we have a suspend function that basically returns a single value. But in the flow, we can return a multiple or we can emit a multiple value sequentially from that particular flow. And for example, you can use a flow to receive a live update from the database. So all of the code operation that we perform in our database can have a live update to our UI using a flow. And flow are built on top of the coroutine. So as I have already mentioned that flow and the coroutines goes together hand by hand. So the flows is built on top of the Kotlin coroutines and can provide multiple values. A flow is a conceptual, a stream of data that can be computed asynchronously. So here it's a stream of data, and if you are familiar with the RX Java or the RX Android part, it's also based on the stream of data. So which is also does everything on the asynchronously. So the flow over here also is a conceptual stream of data that can compute everything asynchronously. The emitted value must be of the same type. So let's say we create a flow of the integer type or a string type, and then flow can only emit of the same type of data. Whether you create an integer or a string flow, then it can only emit that particular value. A flow is very similar to the iterator that produce a sequence of values, but it uses a suspend function to produce and consume the value asynchronously. So on the Kotlin flows over here, everything is done asynchronously. We are doing everything asynchronously. We are not using any UI thread over here. That's the beauty of the Kotlin coroutines. Sorry, the Kotlin coroutines and the flow. So which means that it goes together hand by hand, as I have already mentioned. This means that, for example, that the flow can safely make a network request to produce a next value without blocking the main thread. And there are three entities involved in the stream of the data that we need to understand. So the first one is a producer. Producer produces data that is added to the stream. So that thanks to the coroutine, the flow can also produce data asynchronously. So here the producer is the one that is producing the data for our to the stream of the data. And optionally we have over here intermediaries which can be modified the value emitted from the stream or the stream itself. So let's say we are emitting some values and there is an optional intermediaries which can be used to modify that particular. Let's say you are emitting some values and you want to modify that values before it reaches to the consumer. So you have a list of you are emitting the user and you want to modify as to the employee. So there we make use of the intermediaries. And a consumer consumes the value from the stream. So in Android, the data source and the repository is typically a producer. So if you are familiar with the MVVM architecture, the repositories act here as the producer of the data. And the UI data that has the view as a consumer. So basically UI which will consume our data stream from our repository. And on the sometimes we may also have a view layer as a producer, because there is a user event triggered. So whenever the user event is triggered, we may produce some data from there. And on the same hierarchy down below, we can have a consumer for particular of that data. So we are in the user or the UI side, user has some triggered some data or the input event, and then we are consuming that data in down below the hierarchy. So this is some basic concept that we need to understand about the Kotlin flows, and I hope you guys got it. And make sure you have a Kotlin coroutines background before we move into the coding part. So let's meet up in the next lecture, and we will be starting and creating our project. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue. So I have already created one empty project over here. You can just go and create an empty project before we get started. So just make sure you create an empty project. I have just created an empty project. Nothing is over here, just created a main activity and layout for the main activity. And the next step is we'll go to the build.gradle for our module app, and we need to add the dependency over here. So we need a Kotlin coroutines dependency first of all. So let's go back over here on the Kotlin coroutines on Android. So I'm going to this site, which is you can come from here, and we'll add a dependency from here. So make sure you add a dependency for the Kotlin coroutines that's Android. Just copy it, and I will add somewhere over here below, and that should be okay. And also I'll add the link, so if I want to go back and check the documentation on it, so it will be more easy. And then I will just synchronize it. So if you want to take a look on the Kotlin coroutines, you can just go through the documentation over here. And I hope you already have some of the basic concept about the Kotlin coroutines, so that should be fine. So I think we have already added it, and if I go to the main, and now if I try to find something like a flow, then I should be able to get, so val flow, which is equals to of the flow. So I should be able to get the Kotlin coroutines flow. Yeah, that's up over here. So that should be fine. So that's it for this lesson. We have added the Kotlin flow or the Kotlin coroutines successfully. So we will be moving forward on our next lecture. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue. So before we get started on the flow side, let us understand some basic concept about the asynchronous or the asynchronous programming. So what I will do is I will try to add a new Kotlin file over here and call it as a help helper. So we have a helper over here, and I will try to create one new file over here. So let's say I will create a val and user list. So we have a user list, which is equals to let us say a list of, and I'll just go and remove this and create a list of, let's say a user 1, and let us add a user 2, and this should be of the, let's say a user 3 and user 4, and we have of the last one, let's say user 5. So we have a 5 user over here, user list. And now if I go back to the main activity over here, and let me create a one function. So private function, let's say print user. So we have a print user, and we have a list. We have a user list, right? So we have a user list dot for each. Let me make use of the lambda expression user, and since we have a user, I will just log dot b, and a tag, let me create a tag over here. So I'll just say companion object, and private, let's create a constant val of the tag, which is of equals to, just keep the class name over there. Okay, so now I can make use of the tag over here, and then I'll print the user over here. Okay, so I'll call this function from the onCreate over here. Sorry. So this will be, I'll just say print user, and then after that I will just create another log. Just copy and paste it over here, and I'll just say print user umplt completed completed. So print user is completed. So we are just trying to understand about the asynchronous programming over here. So this is a synchronous programming because nothing is evolved on the background over here, or no asynchronous program is evolved. So if you try to run this application, you will see that this will go and run this program and print all of the user, and then only come back over here. And let us create another function which is of a suspend function. So I'll just call it as a private, and the suspend function, and I'll just call it as a let's say a user, or I'll call it as a print user user list. So print user list, and this will also make use of the same user list dot for each, and I'll just call it as a user, and let's go and log that one. Log.d, and I'll just tag comma in the user, and let us call that function from here, and I'll call it as suspend suspend function to print user list, and I'll just call it as a print user list over here. And this is a suspend function, so we cannot call it from the normal function, so we must call it from the coroutine or from another suspend function. So I'll just create a one. Okay, I'll just create a new coroutine scope over here before we can call this suspend function. And let us create a coroutine scope, coroutine scope over here, and coroutine scope, and I'll pass the context. So I'll just pass the dispatcher dot, and I'll run it on the background thread, and dot launch it. So inside this I can call that the suspend function. This is all from the Kotlin coroutines, nothing to do with the Kotlin Flow over here. So we are just trying to understand the asynchronous programming over here. So now I will just try to run my application, and okay, so I need to forget this one. I need to print this one over here. So print user completed from suspend function. So here we are running a suspend function, and after it's complete we are trying to print it something over here. So let us try to run the application, and I have to filter it out by this. So go to logcat and change to the debug, and make sure you select your package name, and I'll print over here. So let us see the difference. So first one, we can see that user 1 2 3 4 5 is printed, and the print user is completed is printed over here. So which means this print user run synchronously, and it went to over here and printed all of the user, then again come back to here this line and printed for us this line. But in the coroutine scope over here, or the suspend function, if you take a look what happened over here, you can see that it went over here, and you can see it went over here, and but instead of waiting to finish this task complete, it just go and printed out this one. It went to this next line. So this is a asynchronous over here. It's not waiting for this particular function to complete before it can move on to the next or your next function or your next logic over here. It's not waiting. So it's not waiting for this print user list suspend function to complete before it can move on to the next code execution. But here on the normal synchronous programming, you can see that it has to wait before it can move on to the next execution or the next line of the code. So this is the basic difference about the asynchronous and the synchronous programming. and I hope you got it. So let's talk about the Kotlin Flow on the next lecture. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lesson. So in this lecture, we are going to learn about the Kotlin Flow. So this will be our first Kotlin Flow that we'll be learning. So let us get started on it. So first of all, I don't need all of these things, so I can just comment it out. And here we below, I'll just say SIMPL simple flow, and I need to create a function that can return some flow value. So I'll just say private function, and we'll call it as a SIMPL simple flow. So this is our first flow example, and the return type, I want to return some value FLOW flow. The flow generic type, where is here? So we learned before that it can return only a single data type. So we say that out is of string or integer depending on your requirement. So we want to return a list of the user from here. And okay, so we have a flow which is returning a string data type. Let's create a flow builder over here. FLOW flow. You can see that it takes a suspend function. It's a flow. So when we create a flow builder can, we don't have to create a suspend function for this flow because it can call a suspend function itself. So flow is on top of the built on top of the Kotlin coroutines. So which means that we can use a suspend function over here. Like if you want to make a, let's say, call a delay function, delay. So this comes from the Kotlin X coroutines. We can make use of this function, and if you go to this delay function over here, okay, let me import this one. So I think I will import from import this function dot delay, and I can just remove this one and pass the value as, let's say, 500 millisecond, right? And if I go to this one, it says a suspend function. So this is a suspend function we can directly call inside our Kotlin Flow builder. If you try to call this function without any Kotlin coroutines, then it will give you an error, right? Let's say if you try to call this one over here, it gives you error that it can only be called from the another suspending function. So that's the great thing about the Kotlin Flow, that it works together with the Kotlin coroutines, and that's why we don't have to make use of the suspend, or we don't have to create a suspend function over here. So delay, we want to delay about the 500 millisecond over here before we can execute some code over here. So we have a user list and dot for each, sorry, let's say for each, and we have a user, and now we have to emit this value. So how do we emit is, let's say we call the emit function, and this emit function we have to pass a value of the user. Now it can emit a value for us, and I think we call this one inside of the for each loop. That should be good enough, not the outside, because we want to suspend for the 500 millisecond before it can emit a next value. Or you can also call after the emit, and it will wait for another 500 millisecond before it can call another next emit value. Okay, so we have a simple flow over here. Now what we can do is we can just call this function from here, and let us take a look on our logcat what is actually printing for us. So just wait for it, and let's see what it's going to print for us. So you can see it print us nothing. So why is that? If you can take a look, we are emitting the value, but over here in the Kotlin Flow we have to take a note over here. If you are familiar with the RxJava observables, there is a hot and a cold observables in RxJava. Similarly, a Kotlin Flow is a cold observable over here. We can think it as a cold observable, which means that if we never collect the value from the flow, it's not going to print, or it's not going to do anything. So similarly, like a cold observable in the RxJava, where we have to subscribe it, then only it's going to print, or it will give us the result. So similarly in the flow, it is like a call observable that we must collect the value from the flow in order to walk. So now I can just call that dot collect. So now we have a collect function over here. Now we get a string type. The output is over here. You can see the string. So we get a string value. So I'll just say user, and I can just log that user over here. Log the d and tag comma, and I'll just print out the user from here. Now it says it's the suspending function again. So we have to call it from the Kotlin coroutines. So I can just copy this section, I think. So this is a suspending function. So we just have to call inside our Kotlin coroutine. Just paste it over here, and that should be fine. And let's run again, and let us take a look on the logcat. So we will see now some of the printout over here. So here you can see that it's printing now sequentially. Every 500 second, a millisecond is going to print 1, 2, 3, 4, 5, right? So that it is how. So this is our first Kotlin flow that we have learned how to make use of a Kotlin flow and how actually it works. And also we understand some the call observables over here, how we have to make use of the Kotlin collect to collect the emitted value from our flow. If we never collect it, it's not going to do anything. So just make sure that one. So I hope you understand this one, and hope you enjoyed it. So let's meet up in the next lecture. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lesson. And on the previously we saw a simple flow, how to collect it and how does it actually works. And we learned about some basic concept about the call observables over there, quite similar to RxJava. So let's dig a little bit deeper on it, and let's see how do we collect a flow multiple times, and what are the consequences, and what are the results that we're getting if we are collecting a flow multiple times. So what I will do is I have a same function over simple flow, and this is the flow, and I'll just make use of some variable over here. I'll just say as a flow1, and then I'll just call that a user over here. So I'll just create another launch another coroutine over here, and inside this I'll just call this one same function multiple times. We are collecting the flow multiple times over here. So it's same like RxJava, where in the call observables we can collect them multiple times. Similarly on here in the flow, Kotlin flow, we can collect the flow multiple times, so we don't have to worry about, like, let's say if we already collected the flow, then on the next collect, like let's say we are not going to get any value. So this is a flow second, and I'll also launch the another one another scope over here, and let's say this is a flow 3. So here we are collecting the same flow multiple times, so flow 1, flow 2, and flow 3. So we are collecting the flow multiple times. So let's try to run, and let's see the result, or let's see the output that we get when we collect them multiple times. So here you can see flow 1, it's went to the flow 2, flow 3 is running as asynchronously. So after the first one, this coroutine completes, then it's going to run on the flow 2, flow 1, 2, and 3. It's running, and it's getting emitted value asynchronously over here, and we are not losing of any of the values. So no matter how many times we collect that particular flow, we are going to get the same result from that particular flow. We are not going to miss any of the values. So if we may be wondering that, let's say if I collected the flow already, so can I collect the second time or the third time from the another place? Yeah, that should be fine. You don't have to worry about it. So we can collect the flow multiple times since it is a code observable over here. And let's I think I will put this inside over here. So let us run in the concurrent or asynchronously. So if you run this one, everything should run asynchronously over there. Go to the logcat, and we will see that it's running the flow 2, 3, 1, everything is running asynchronously over there. So that's a great thing about the flow, and we can collect it multiple times and there is no data loss, or the emitted value will never be lost over here. So I hope you understand it, and hope you enjoyed this lecture. We'll meet up in the next one. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lecture over here. And in this lecture, we are going to learn about the flow builder, and there are different types and different ways to create a flow builder. And on the previous, we saw about the simple way to create a flow. This is the first way that we make use to create a flow over here. So flow, and there is a lambda expression that we can make use to create our first flow build over here. So this is a flow builder that we can call it. And the next are the different another two ways that we can basically create the flows. So let's go to the helper over here, and I will just create a val and flow user list. So let's create a variable of the flow user list, and I'll just say flow of. So we have a flow of function which is comes from the Kotlin X coroutine dot flow. I can make use of flow of builder to build a flow over here, and I can just copy this section, just copy it and paste it over here. And why it is giving me an error? Okay, so I have this one, so let me remove that one, and I just give a 6 and 7 and 8, I think, and the 9 and 10. So using the flow of, we are converting this all of this value, the elements over here, as a flow. And this way we can, this is another way to build a flow. So now we have a flow user list. Let's go and collect this flow. Since this is a flow, we have to collect it, otherwise it's not going to do anything. So I'll go over here and I will comment out this one. I'm not going to use it, so let me comment out this one, and then I will just copy this section, I think, and just go down because we have to collect that flow. And I think I'll collect inside here, and let me remove this launch. Okay, so we have our coroutine scope, and now we have a flow user list dot. We can directly collect that one, and we can just print out that log.d and tag comma. We can just print out the user over here. So you can see that from the, we can just create a element, we pass the element to the flow of, and then create the flow over here using a flow of builder, and then we can just collect that over here and print out. So if we run this one, we should get that printout value. So if we go to the logcat, and yeah, we get a 6, 7, 8, 9, 10. So that's great, right? And the next way that we can make use of Kotlin Flow to build is to go over here, and we can convert this list, the normal list, to a flow. So there is another way that we can directly convert any list type to a flow. So that is another builder. So I will go over here and launch the second part over here, and over here we will use a I think I will remove this one first of all, and then I will go over here. It's a user list, so I will call the user list over here, user list dot as flow. So you can see that it's another way or another flow builder as flows, which can directly convert the iterable to a Kotlin flow. So we have a flow, and then I can directly collect this flow, right? And from here I can just build a lambda expression and I'll just say this is of a user, and then I can just go and print that value over there. So I think that should be something like this one. Just copy and paste it over here, and as well as over here. So this is of a flow 1, and I can just call it as a flow 2. So if I run this one, we should get the same printout. So if I go to the logcat, and yeah, we get the same printout over here. flow 1 2 6 7 8 9 10 and 1 2 3 4 5 6 8. This is another user list, right? So that's why it's a different printout over here. So I hope you guys got it, how to make use of a different kind of a flow builder over here, the simple way we use a flow and then lambda expression to create our first flow. And we can also use to directly convert any iterable as a flow, then collect it, and make sure you collect it, because if you never collect, it's not going to do anything. And another use of the flow of, so using a flow of builder, we can also create a flow you passing the any elements over there. So I hope you guys got it and enjoyed this lecture, and we'll meet up in our coming up videos. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lesson. And in this section we are going to learn about how to cancel a flow. So let's say we have some requirement, right? We also have to take care of when our flow should be canceled. So let's say if you have a very long running task that the flow is doing, and we should be able to cancel that one if depending on our requirement, whether our activity is destroyed or whether it's based on the timing. So there should be option to cancel a flow. So in this lecture we are going to see some of the different ways on how to cancel our flows depending on our requirement. So the first one we'll see about the basic way. So cancel flow, I'll just go and I copy this section. Instead of creating a new one, I'll copy this and paste it over here. And I'm not going to use all of those. I'm just going to use a one first. And I have increased the timing for our delay to 2 seconds. So every 2 seconds it should go and emit a value for us. And now if I go and run the application, so let us try to run our application for us. And if we go to the logcat for now, we should see the printout of our flow every 2 seconds, right? And what we will do is now we will add a timeout over here. So if the time is out, then we should cancel our flow. So with the Kotlin coroutines, we have a built-in function. Let's say timeout are null. And I'll pass over here is 2000. So I think I will keep around 5000. After 5000, we should cancel our flow. So I'll just cut this section and paste it inside. So this should cancel with a timeout of every 5000 seconds. Then it should cancel the flow. So if I run this one again, and let's go to the logcat over here. And now it's printing 1 2. And after 3, I think it's, yeah, after 3 it should not print out because the flow should be cancelled based on the timeout we have provided, which is of 5000. So this is another way that we can make use to cancel our flow, but it's not recommended anyhow. And let me show you another example over here. So let's say I will just cut this section and I'll just comment out this one. And, let me paste it over here. And if I run my code now, and let me go to the logcat over here, we should see the printout. And let's say we have a device, and let's say we go create or destroy our activity or the fragment. You can see it's still running in the background. But that should not be the case, because our UI, which is consuming the emitted value or the stream of that particular data, we are passing to the UI section. And suppose your UI is not there and you are passing that value to the UI, that will obviously go and crash your application, or you may have a memory leak. So there are a lot of side effects of this one. And this should not happen. So whenever your activity or the view is not there, the stream should also stop, or it should not get displayed, or you should stop the flow of execution. So that's how we should do. And since with this structure over here, what we have is we are collecting the flow, even the UI is not there. So the best way to handle this case or this scenario is to make use of the architecture component. So we have an architecture component, Android lifecycle, which can help us to eliminate all of those stuff. So if I go to the lifecycle over here, so we can see the use Kotlin coroutines with the architecture component. And if you are familiar with the Kotlin coroutines, then you should already know about the architecture component, like a view model scope, a lifecycle scope, and the live method. So all of those come on the architecture component. And if you are not familiar with these architecture component like a view model scope, lifecycle scope, just go and take a course on the Kotlin coroutines that I have already. I created a course on the architecture component using the Kotlin coroutines. So make sure just go and watch that one. And because I'm not going to explain all of those over here, so we have a lifecycle scope we will be using for our current practice, because we have to cancel that Kotlin flow whenever the lifecycle of that activity or the fragment is destroyed or not available for us. So using the lifecycle scope, we can accomplish that one. And I need to add a dependency for that one. Just we will copy some of the dependencies. So lifecycle version, just copy these dependencies, and I will go and add it on top over here. And then I need to add, let me go over here and copy. I'll just make use of a life cycle only because we are not using a view model and the live data currently. So if you want to add all of those, that's perfectly fine, but I'm just adding the life cycle because I'm interested in the activity or the fragment life cycle. Just copy this and I'll just paste it over here. And let me also add the link in case I want to go back and check something. I'll just add it over here. Okay, so we have added the lifecycle dependencies. So I'll just synchronize. This is architecture component lifecycle. So lifecycle, our component perform action in response to the change of the lifecycle status. So activity has its own lifecycle, fragment has its own lifecycle, view model has its own lifecycle. So based on this, it's aware. So it's already aware that when the lifecycle is ended or lifecycle is on pause. So it's really helpful. So make sure you try to read this documentation if you are not familiar. So I have already added the lifecycle over here. Now I can make use of these certain things. So I'll just go and make use of a lifecycle scope over here. This comes from a lifecycle Kotlin coroutine scope. So I can add that one. Dot, we have a different mode like a launch when created, launch when resumed, launch when started. But I'm not interested in all of those. I'll just go and create a launch over here, launch builder. And here I'll pass the, let's say, a dispatcher. So I just want to pass the dispatcher that let's run in the background since this is a long running task. And over here we have a Kotlin coroutine scope. Now I will just go and copy this section and paste it over here, right? So I'll just go and paste it over there. And now if I run my application, so it should be lifecycle aware now. So it should know when our activity is destroyed or everything. So I should go to the logcat. Now you can see it's printing out. So okay, so I think this is the one. So I need to uncomment this one. So let me comment out this one. It will be a bit confusing otherwise. So let me run it again one more time. Okay, now we can see that flow 1 is printing every 2 seconds. The user is getting print from here. And okay, so everything working fine. So now what we need to test is whenever our activity or the fragment is destroyed, the flow should stop, right? So now if I run again and let us try to destroy our fragment from here or the activity. So if I go back and now you can see the flow should be cancelled or stopped. So you can see that the flow has cancelled itself. So you can see based on the life cycle we have made it that okay, so life cycle is not there, so just go and cancel the flow. So it went and cancelled our flow. Now if I again start the activity, it should start again. So if I start again my activity, so now it knows that activity is on view, on the life cycle has come to on the live, then it will go and start our flow again. So this is a better way or a great way to cancel all of our flows. So I hope you understand it and try to go and read more and practice more on this. And let's meet up in the next lecture. Till then, have a great day. Yeah, hi there and welcome back, and let us continue with our lesson. And in this section we are going to learn about the filter operator in a Kotlin flow. And if you're familiar with the RxJava operator, it's quite similar. So let us go and take a look on our first operator, which is on a filter. So what I will do is I'll go to the helper, the Kotlin file over here, and I'll create a val and age list. So age list, which is of equals to, let's say, a list of, and I'll just remove this section and I'll just add a 10 comma 20 comma 30 comma 40 comma 50. So let's say we have a age list, and this is a age list 10, 20, 30, 40 and 50. So let us create a new lifecycle lifecycle scope over here, and let us launch that one. Let's say launch it, and in context I'll just make use of a dispatcher that, let's say, IO, and over here we will I will just create, say, age list dot as flow. Let us convert it to flow, and I'll make use of dot filter it. So let us filter that one, and on the filter section I'm getting the age, and let's say the age we want to filter each of, let's say, if it is modulus to 3 and the remainder is of, let's say, 1. So when the age is has a remainder of 1, then we should filter that age, and we should collect. So CO collect it, and we collect the age over here, and then we will just log dot d that age and tag comma, let's say, age, print out that age, and that should be true string. Okay, so I think you guys got it over here. What we did over here, which actually we convert the age list as to a flow using a as flow builder over here, and then we use a filter on that particular age, and we say age, when we have an age, we will see whether the remainder is 1, and if there is a remainder is 1 on that value, then we will pass down to the collect, and then we'll log that one. So make sure that the filter should be before the collect, before you collect that particular the value that is emitting. So we should filter out before the collect, not after the collect. So you should always put the filter before the collect. So let's try to run our application, and let us log it, and let us see the result that we get over here. So I'll go over here, and I get the 10 and 40. So that I think is correct, because 10 when 10 divided by 3, we get a we get the remainder of 1, and on the 40 we also get the remainder of the 1. So that is the correct filter we are getting over here. And also I will try use another one. So let me try to copy this, and let us filter in for our let's say a user list, and we have let's say a user, and if the user, let's say, each of equals to, we say user let's say 3, then we want to get a user over here, then print that user over there. Can remove the toString from here. So it's the same thing. So we use make use of the user list that we have, and then we filter it out by the user 3. So only if the value is equals to user 3, it should go and collect that value and log for us. And let us try to run it again. And I'll go to the logcat over here, and yeah, we get the 10 and user 3 and 40. So I hope you guys got it over here, how to use a filter operator in our Kotlin Flow. So let's meet up on the next lecture. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lesson. So in this lecture, we are going to learn about the map operator in Kotlin. So let's see how to make use of a map operator. And in the previous lecture, we learned about the filter operator. So let's go and take a look on map operator. So what I will do is, I think I will just make use of this previous code. I think somewhere we have, I think not this one, I think it's here. So let me copy this one, and I think I'll paste it over here. So we are applying a filter over here of the age, and let us try to apply a map over here. So just Map is an operator that transforms the one type of object to the another one. So let's say you are getting age, and you are getting as an integer value or a double or a boolean. So we want to convert it to a different type of value. Let's say I want to convert it to the string. So I can transform from one object to the another, or from one data type to the another. So it's really useful. And if you are familiar with the RxJava map operator, it performs the same operation over here. In RxJava, we get one kind of object and we transform it to the another object using a map operator. So here we can do the same thing using our Kotlin Flow over here. So let us try to make use. I'll just say age, and since I'm getting the age, now I want to transform this age, which is of our data type, let's say of our integer. Now I can convert it to, let's say I want to convert it to the string over here, and I get a string over here. So I can remove a toString over here, and if I run this one, now we should get that particular age print out, and I have converted that, or I have transformed the age which is of our int to the string type. If I go to the logcat, I get a value. And if I want to add something to over there, and since this is a string type, now I will make use of the let's say, and let us try to do something that I want to transform from one object to the another object over here, and I can remove the age that to string, and okay, so I have to remove this one. Okay, so what I did over here, age. Okay, so what I'm doing over here, I need to put this one, and let's say age, and then I want to concatenate with something like some value. So age, and I'll just give an age over here, or in front of that particular here, I'll just say age, and yeah, I think I can remove this code over here, the bracket. And now I have transformed that to a string, and I should get some print out using an age and the particular value. If I go to the logcat over here, I can transform that and print out a different object over there. So this is one way of transforming from one object, one data type to the another data type. You can do the same thing with this one. I think we have another one over here. I think I'll just copy this section and just paste it below over here. Now we are getting a user as a string type. Then I can apply a map operator which can simply transform my object from the user. So user, and when I have a user, let me transform it to different value. So I will just say that dollar, we have a user, and I will just give as a name over here, and that should print out the name and the user. So if I go and run this one, and let us take a look on the logcat over there, and we get a name of that one, and I get the age. So this is how we can make use of the map operator. So map is basically used to transform one object to the another type. So if let's say you have a different object, you are getting an integer, you want to transform it to the string, or you have a user or your employee object and you want to transform it to the from employee to the user object. So all of this can be done using a map operator, which is a very similar, and it's a very similar to the RxJava map operator over here. So I hope you enjoyed this lecture and learned something new over here. So let's meet up on the next lecture. Till then, have a great day. Yeah, hi there, and welcome back. So let us continue with our lesson, and in this section we are going to learn about the transform operator in Kotlin Flow. And on the previous we learned about the map operator, and the transform operator is quite similar to the map, but we can say that using a transform operator we can perform more complex transformation of our particular object. So let's go and take a look about the transform operator and how does it work and how it's different from the map operator. So we have okay, let me just create the same thing. I'll just copy this section instead of typing, so I'll just paste it over here, and I'll just convert that one, and instead of the, I'll just remove the filter for now, and I have a map, and I'll replace it with the trans transform operator, and I can just remove this because I'm not going to use that one. And I have an edge over here. Now using a transform, I can emit a value. So we can emit a value on the collect, right, when we have a value, but in the transform we can actually go and emit a value over here. So I'll just say over here edge, and that should be of the edge that I'm getting, right? So I'll try to just emit a value of our edge that we are getting, and I'll just say that edge, or I'll just say the value is getting trans form. So the value is getting transformed over here, and then I can actually go and transform the value. So emit, and I will just say that I have a edge, right? And then I would say that I would get the edge value and print out. So now I get a value as a edge as a string over below, and I can just say as a just simply as a value, and just print that one over there. Okay, using a transform, you can see that we can emit a value, and which is not available for our map. So you can see that if I try to run this one, before we are logging that particular emitted value, we can actually emit some other values over there. So if you go to the logcat, and you can see that we can emit the value, right? So we are emitting an age 10, and the value is getting transformed, and we transform the particular value, and then we go to the next. So this is how it actually works. A transform is transforming the value from one type of tree to the another type, as well as we can emit some values over here before actually we can go and collect. So before you are printing that one, so which is available on the map, we don't have option to emit that one, but using a transform we can perform some more complex transformation over here, and then that's it. So I think you guys got it, and how to make use of transform. And if you have more complex requirement for the transformation, or from transferring from mapping the one object to the another, then it's recommended that we use a transform, or else map is also a quite similar form, but it has a lesser option than the transform. So I hope you guys got it over here. Just try to go and practice it out, and we'll meet up in the next lecture. Till then, have a great day. Yeah, hi there, and now welcome back, and let us continue with our lecture. And today we are going to learn about the another operator in Kotlin Flow, which is of size limiting operator, take. And let's say we have a requirement where we want to cancel the execution of flow after certain of a limit. So let's say we have a list of 100 user, and let's say we just want to take the 10 user, or the top 10, and we want to we want to cancel the execution of flow after it reaches the 10 limit. So let's see how to limit a particular flow execution. So we will go and take a look, and I'll just copy the same code from here, just copy it, and what we do, I'll just go and paste it below over here. And now we have a s list as a flow, and I can just remove this one, and I'll just make use of a take operator over here, take operator, and I just have to pass the count. Let's say our current user, we have a 5, and I'll just take a 3. So after 3 so let me convert it to a string. So after 3 I want to terminate. Just take a count of a 3 from this particular list of the user and terminate it. So I'll just go and run this application. So we should only get the first 3 from here, which is user 1, 2 and 3. After that it should terminate. So go to logcat, you can say that okay, so it was over here, not the list of the users, sorry. So it should be 10, 20, 30. It just got the first 3 of the age list got the executed or emitted, and the rest got cancelled. So if I go and run the same thing for our list of the users, so I'll just say user list, right, as close, and just take a 3, or let's say just take a 2 first, and then I'll just remove this one, it's not needed, and then let me try to run this one. So let's go to the logcat over here, and we should see the print out of user 1 and user 2, and after the 2 emitted value, then it just take a 2 and rest got cancelled over there. And I think you guys got it. So this is a simple way how we can limit the rate using a take operator. This just take a certain value and terminate after that particular taking of the particular limit. So let's say I have a 3 limit, then after 3 just terminate the flow execution. So that's all for this lesson, and we'll continue with our lecture on the next video. Till then, have a great day. Yeah, hi there, and welcome back. So let us continue with our lesson, and today we are going to learn about the terminal operator in Kotlin Flow. And there are different kind of terminal operators in Kotlin, and the basic one that we have already learned, and I hope you have already used it quite frequently, which is a collect. Collect is also a terminal operator that we have used. It's the basic one, and we basically use most of the time we use a collect to collect the Kotlin Flow, and that is a terminal operator. So there are other terminal operators that we can also make use. So let us take a look on some of the other terminal operator that we can make use. So I will just go and I think copy the one, I think this one. So let me copy this section and paste it below over here. So we have a edge and as a flow, and what I will do is this is a collect. This is a terminal operator already, so we will replace this one with another one. So just remove this one, and I'll just remove this one too. So first of all, I just want to show you that I'll just map it. So sorry, map, and I have an edge, right? And then using that edge, I will perform some operation. So let's say I want to, okay, never mind. Just first of all, I'll just return a simple edge only without any mapping over there or transform to any another object, and then I'll make use of the one reduce operator, which is of another terminal operator. So let us make use of a reduce operator over here, and let me use a lambda expression, and I'll just give a comma b over here. We have a 2 value over there, the first and the second, right? And then what I want to do is I want to do the calculation for all of the values that we receive. So I'll just say a plus b, or we can just call it as okay, so that should be okay, a and b. Then we calculate this one, and I'll just say val, and I'll just say sum. That should return a sum of this. Reduce is a terminal operator. Now what we are doing is over here we are getting all of the edge from our here, the list of we are getting 10, 20, 30, 40 and 50. So this reduce will actually go and sum up all of the values and just give us a one single value. Instead of us emitting a single value, we just want to emit a one single value and sum all of the value that we have over here. So we have 10, 20, 30, 40 and 50. So we want to sum all of this and just give us a single value instead of emitting a single value. So now if I go and log that sum over there, so log.d, and I'll just say tag comma and the sum, right, dot to string. So now I have, if I try to run this one, I should get sum of all of these values. So it should be a 50, 90, 90 and 20, 20, 40 plus 150. So I should get a 150 as a value. So if I go to logcat, and I get a single value of a 150 over there. So that's the thing, that another terminal operator of which is we reduce to a single value. Instead of emitting and collecting a single value, we just reduce and collected a single value and sum all of that value. So if I add do some operator over here, like if I do some mapping over here, I want to convert and add one value. So I should get, it should add a 1 to each one. So it should be 11, 20, 21, 31, 41 and 51. So all of these calculations should give us a 155, right? So if I run this one, we should get that particular value. So if I go to the logcat, I should get 155. So that is how the reduce terminal operator works over here. And similarly, we can do the same thing for our, let's say I'll just get a value over here. and it should be of a user list, and I will say this is of the user, and I will just say a user and reduce. So it will just go and get the first and second, so it will just add on, and at the end will just give us a single value of this value. So I'll just copy and paste it over here, and I can remove that to a string. I'm not going to use that one. So let me go and just run this one, and we should get a single value of, and combine all of the user list and get a single value over there. So go to logcat, we get all of the user 1 2 3 4, and now if I want to do some formatting over there, I can just do the mapping, and let me say that I will make use. Okay, so I will the dollar and the user, and I can just give some space over there, right? And then I can just go and run again. We should have some space over here. So user 1 2 3, yeah, we get that value over there. So this is we make use of the reduce operator, and let us make use of the another sum operator that we can make use. I think we will make use of the simple flow, and over here I'll just reduce that one to 200 millisecond, and I'll just copy this section, just paste it over there, and I will just remove all of those. So another terminal operator we are going to use is, okay, I will just make use of a simple flow over here, and instead of as flows, it's already a flow, so I'll just say to list. And now this to list is another terminal operator. So we have a value, and now we, instead of emitting each value for our flow, we are collecting it to a to list, and then we want to make use of that value. So I'll just say to string, so we just want to print out. So if I go and run this one, it should collect all of the emitted value and print out as a list for us. So if I go over here, and we get a list of the user. So this is another terminal operator, to list, right? And we have some to list, to reduce, and also there is another one we can make use of, which is of to, let's say, to set. So this is the same one, and if I run this one, I should get the same printout as to list and the to set. So if you go over here, we get the same return type over there. And the another one also we have, so let me just give, and I'll just say simple, that I'll just collect the first one. So this is also another terminal operator, so I'll just say first, right? So here we get the first one, and this should collect the single or the first value and print out for us. So I'll just remove this one. The first value should collect it from here, and I'll just run this one, and let us go and put simply the logcat. We just get the first one, so the first value, the emitted value, we capture and print out in that one. So there are other one. The basic one we use, basically we use some with the flow we use a to collect, basically is the one that we are using, but sometimes we also use a to list and to set if you want to have all of those stuff. So these are the basic terminal operator that we can use with the Kotlin Flow. So I hope you guys got it, and it's easy to understand, not so difficult. You can just practice. And this is of the, I just said the reduce operator, right? So I can just terminal operator of the reduce, and I can just comment out, so easy to understand, right? And just comment this one also as a reduce, and this is of the to list, so I can just call it as a to list, right? And the another one is of, this is of a to set. And then finally we have last one that we learned just now, each of the first. So there are different kind of terminal operators. The basic one is of the to collect, so just make sure you remember that one. And we also have other like first, to set, to list, and the reduce. So that's all for this lesson. Hope you enjoyed it, and we'll meet up on the next lecture. Till then, have a great day. Yeah, hi there, and welcome back. So let us continue with our lesson. And today we are going to learn about the flow execution completion. So let's say that when your flow got executed and after it got completed, you want to get notification or you want to perform some tasks. So how do you identify that particularly the flow has execution has completed, and then we can perform other tasks based on it. So there are basically two ways. One is of imperative completion and another one is of a declarative completion. So using this both way, we can identify that flow has been completed. So let us go and take a look on how do we actually go and use it in our code. So first of all, I will go and create a private function over here, private function, and I'll just call it as a age flow. And this is a function, so I need to return type as a flow, and type is of int, and which is of equal. So I'll just convert my age list to the float as flows, right? And then I will just go and transform that. I want to add some transformation, so I have a age, and I will check over here if I'll add some condition over here. If the age is of equals to 30, then I want to do something over there for the age. So I will just say emit. I have to emit a value, so I have a age plus 1, so I will make it as a 31 if it is 30. On the else side, if it is not the age that we define over there, we will just emit the value of the age. Okay, so that's good. I think you guys are FLOW. I think you understand it over here what we are actually doing. So we convert the age list as a flow, then we transform the age and add some condition over here. Based on that condition, we are emitting the value. And then I will just go over here and create a lifecycle scope over there. And lifecycle scope that launch and the context of the dispatcher, right? Dispatcher.io. So let's do it in the background. And so we have to make use of our try over here, try and the finally block. And this is a imperative completion. So whenever our block over here try completes, then we get a finally block. That means it's an imperative way to identify that your flow has been completed. So over there we will just go and launch, or I can just call it as a what we have the function name age flow, right? Age flow dot. I will just collect that flow. So col and collect that flow as the age, or I can just say as a value, and then I can just go and log the d and put the tag and value dot toString. So this should go and print out the log for us. And after we have, then we will just finally say log dot d, and I'll just say tag comma, I will just say the flow as complete, flow has completed. Okay, so we will just go and run this one, and let us take a look at the output, and we'll see that 10, 20, and we get a 31 because we have applied the transform over there, and then 40, 50, and finally we get the flow has completed. So this is a one way of our imperative completion. We will know that the after this block has been completed, then we get a finally, and here we can do some other tasks based on the flow has been completed. And the next one is of our declarative way. On the declarative way, we have to write, it's a bit different, and let us see how we can do that. So I'll just copy the same thing, right, and just paste it over here, so we don't have to make use of our try class block over there. I'll just copy this code and remove the try and the finally block. Since we have a collect, and before collect I have to make use of a on completion. So there is an on completion function, suspend function for us, which we can make use over there. So in the on completion, I can just go and copy this and just paste it over there, and flow has been completed. So over here I will just say that call this function on completion over there, and just paste. Okay, so that should be identified. We should identify that this is on completion or declarative completion, we can call it. Okay, and for this one we will call it as an imperative, and easy for us to identify which one is which. Okay, and if I run my application, and we should get the same output over there. So this is a declarative, so declarative completion. Okay, so I think it got messed up because of the execution flow. So since it's running asynchronously, then we cannot identify which one is which. So I think I'll just comment out this one for to better understand, right? Okay, so let's go to the logcat and let us wait. Okay, so we got a 10, 20, 30, 1, 40, 50, and the declarative flow has completed. So it's the same, the output is same based on the try and the finally, and this is on built on function for us to make use and see when the completion has happened, what we want to do. So this is one of the imperative way and the declarative way, and I hope you learned something over here. And the thing that we have to take note is that on completion is still on experimental API. So it's you can see that this declarative is an experimental, and its users should not make with a Kotlin.coroutines experimental coroutine API. So this is still on the experimental, and we should add a declarative, add experimental coroutine API annotation on create. So if we add that one, that should be gone. But it's still take a note that when I recorded this video, it is still on the experimental coroutine API. So currently we can make use of the try and finally. That is a better way, I think. On complete is still on the experimental API, and I think it should be stable on the further release of the Kotlin coroutine. And I think that's all. So I hope you enjoyed this lecture, and let's meet up in the next lecture. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lesson. And in this section we are going to learn about the flow on in Kotlin Flow. And if you are familiar with the RxJava, we have a similar kind of function which is of the subscribe on and observe on, where we subscribe and observe on a different thread. So we are subscribing to our background thread and observing it on the UI thread. So the flow on has a similar functionality in Kotlin Flow. So let us take a look on this example. So what we will do is I'll just launch a new lifecycle scope over here, and I'll just launch it, and let me create a lambda expression. And over here what I will do is I'll just go and I'll just make use of a edge flow, and here I will just add a flow on option. So we have a flow on function, and we take a coroutine context. So this is a coroutine context that we have to pass, and what I will do is I will pass the context of the dispatcher. This is a coroutine context dot let us run in the background thread. And now if I run this, okay, so I need to go and get the edge flow, right? edge flow dot, and edge flow dot, I'll just click on completion, and I want to do something on complete, and then I'll just go and dot let us collect it, and we collect it. So on the collect we get the value over here, and on complete we want to log something. I think I'll just copy from the log from here, so I don't have to rewrite. And let's say this, I want to get the thread name. So how do I get the thread name? Is let's get the thread, right? Thread dot current thread dot the name. So this is a thread name that I'm going to get, and this flow has completed on a declarative way. And on the collect I need to log that one, so I'll just log dot d, and tag comma. Here I want to print out the thread name too, so I'll just copy this thread name, just copy and paste it over here, so I get a thread name over there, right? And the next is what I have to do is, let me add some, okay, so I need to print out the value too, so value dollar, let's add the value, and we want to see that this flow on is running on the background. So how do I check each? I'll just copy this section, and I think I will add over here. Why I cannot add there? So I'll just add, okay, so let me add over here after transform. So I just want to add that print the I just want to print out the thread name. Okay, so it should be okay. And now if I run my application, and let us wait for the application to come up, and then we will see that this thread should perform in the background, and this should come to the UI thread or the main thread. The main thread, because we haven't mentioned any of the thread or we haven't mentioned to run on the dispatcher.io, so by default it should go to the main thread. So what we will do is I will just wait up for the application to come up, and let's take a look on the logcat. Now you can see that dispatcher.worker1 and dispatcher.work. This is basically a background thread, and on the main thread we are printing all of this. So on the main thread, we see over here, this is on the main thread, right? So this is on the main thread, and also this is on the main thread. So the flow on over here, the flow on is switching to the different. So let's say later you want to perform a network tasks on the background thread, so we can just make use of flow on. And let's say you want to do a database operation, we can just make use of dispatcher.io to work on the background thread. So let's add the same functionality for each user over here. So since this is a flow, and then what we will do is we will try to go on top over here, and I think I'll just comment out the whole thing over here, and then let us make use of the lifecycle scope. So lifecycle scope dot the launch over here, and let us not give any context over there, and we have a simple flow, right, dot, and flow on I'll just make use of over here, and I'll just say dispatcher dot let us run in the background thread, IO thread, and dot on completion what I want to do, and dot collect the flow. So what I will do is I'll just copy the same log thing from here and paste it over here, and then I'll just copy the same and paste it over here, and that should be of the value, value that I'm getting. Okay, and let me run this one, and you should see that this flow on should run on the background thread, right? And then because I have added over here the log.d, and this should print the log of the background, because this should perform on the background thread, and the on completion and collect should be on the UI thread, because the launch over here by default runs on the main thread. We haven't provided any dispatcher over there. And if I go to the logcat, so where is the logcat over here? Now you can see that we got all of this. The printout over here, you can see it's on the main thread, right? The log that we are printing is on the main thread, and also the main declarative flow complete was on the main thread. But the dispatcher that worker 3 and 2, all of this is running on the background. So here is the one that is doing. So this is the one. So if I clear it out again, and let me run one more time just to show you guys, and you can see that all of dispatcher, and this is the 1, 2, 4,
4 and 5. So all of this is running in the background, so this is printing for us, right? And this is the main, going to the main UI thread, and also this is going to the main UI thread. So I hope you guys understand some of the basic concept over here. It's really simple, and we don't have to worry about so much. We just have to pass the flow on and just say on which thread you want to perform that particular task. So that's it for this lesson, and hope you enjoyed it. So let's meet up in the next lecture. Till then, have a great day.
Yeah, hi there, and welcome back, and let us continue with our lesson. And today we are going to learn about the buffer operator in Kotlin Flow. And it's quite similar to the RxJava buffer, and if you are already familiar with the RxJava buffer, then it will be more easy for you to understand. So let us go and take a look about the buffer operator over here. First of all, I'll create a private function over there, and let us call it as a num flow, and this should return a flow. And sorry, what happened over here? So private function of num flow, and this should return a flow over there, and flow type of, let's say, a int, and let us create a flow over there. And once we have, I will make use of a for loop, and for I in, let's say, of a 1 to, let's say, 10, and just we will log the d tag comma, and let me log the value of I think. Now let us print out the thread over there. So I will go and say log1 and thread, sorry, should be of a thread dot current thread and the name. So I'll get the current thread name, and then I'll just emit the value of I over there. So I have already created a lifecycle scope over there. Now I can call that num flow over here, num flow, and dot, I will just collect it, and when I collect it, I will just log I will just copy the same, I think, just copy this and paste it over there, and then I will finally print out the value of which is of $IT. So if I run this one, let me try to run the application, and let us see the printout. So I will go to the logcat over here, and you can see it is printing in sequence, let's say from log1. Okay, so I think I need to change this one to log2, so it's a bit confusing. So let me run it again one more time, and because it was confusing, log1 and log1. I just want to show you log1 over here, which is on the down. This is a flow, and log2 is the one where we are collecting. So on the where we collect is log2. So we have a sequence of log1, log2, log1, log2, log1, log2. So if you notice this log, you can see that this and this is running in a sequence. So both of this code is running in the same coroutine and have a sequence. So which means that first it comes over here, log1, and then comes over here, and again comes over here, and then comes over here. So which means that if we have some operation that is doing a lot of calculation, or it is taking a lot of time, so which will take a lot of time. So let's say if you want to delay it, let's say it is doing some tasks over there, and it maybe is getting some API record, or we are fetching some record from the API or the backend system. So let's say it has some time to do it. So it's taking 100 milliseconds. Let's assume that it's taking 100 milliseconds over here. And again, on whenever we collect that particular flow, then we are doing some calculation, or we are filtering out, or we are doing some kind of calculation which takes a bit time. So let's say we have some delay over there. We have a delay, let's say around 200 milliseconds. So now the total delay is around 200 plus 1 is 300, which will be on sequence at 300, and 300 into 10 is around 3000 milliseconds of it's taking. The total time will be taking around the 300 milliseconds. So if I want to go and get the total time, I'll just say val time over there, which is equals to time measured time in millisecond. So if I just cut this code and paste it over there, now I can print the log and get the total time. So let us try to print out the total time. So I'll just say over here TOTL total time. This should be of the time that is taken. So if I print now, it should take around 300 or 300 millisecond, 3000 millisecond, right? If I go to the logcat, and you can see that it's printing in a sequence 1 2 1 2 1 2 1 2 till up 10, and total time is of 3000. So this is doing in a sequence over here, but let's say we have only it's taking 100 over there, but it's taking 200 over there for the processing or on the collect side. So why not, what we can do is whenever it's waiting or it's doing some tasks over there, let's say it's performing some calculation over there, instead of waiting, why not we just go and fetch the other record. Now it cannot go and fetch the another record. It has to wait for this 200 millisecond to complete. Then only it will go down to the log 1 and get the another value. But why we have to wait this one? We can do it in a better way. So how we can do it better is when it is doing some tasks over here, we can just go down and get the another value, or within a 200 millisecond we can just go and fetch another 2 record, right? So we don't have to wait for this one to complete, but we can just go and get the another 2 value on this 200 millisecond, because it's taking around 100 millisecond over here. So which means on this waiting time we can go and get another 2 value. So how do we do that is we can make use of a buffer operator. So buffer can also take a capacity, but we are using a default capacity over here. And now if I use a buffer over here, and if I go and run the application, you will notice there is a difference over there. If I go to the logcat now, and you can see that now log 1, which is it's waiting, means it is waiting for another 200, right? So 200 millisecond. So when it want to print out, it has to wait for 200 millisecond. At that time it goes and get a 2 record from below the from the flow, and here when it print out, and again it goes to the log 1 and gets the 2 values. So we are doing a sequence, we are not doing in a sequence over here. So log 1 is operating on a different coroutine, we can say, and the log 2 over there is operating on a different coroutine. So that's why it doesn't have to wait now. Now it doesn't have to wait for this 200 second to complete, and then only we can perform the task. But now when it is waiting, it's going to get the another 2 value for us. That's why it's much faster now. So if you take a look over here, when it reaches the 5, so when the main prints the up to the 5, right, number 5, at that time we have already fetched all the 10 record. Why? Because every time we go and get the 2 value, we get the 2 value when it is waiting for 200 milliseconds. So at the time it reaches of the 5 printout, we have already fetched all the record and buffered over here. So this buffer over here, so all of the record that we have fetched is already buffered over here. So that's why we can print now. So we don't have to go and get the value from the down below flow over here. It's already buffered over here, and that's why we can just go and print out all of the record now. We don't have to go and get again. And then you can see the time taken is quite less over here. Previously it was of 3000. Now we can see that it has reduced to 2000. So it's much faster because it's not doing in a sequence now. It is doing this task is done in a separate coroutine, and this task is done on a separate coroutine. So before the buffer, whatever code is there, it will perform in a separate coroutine, and the collect over here, this is going to perform on a separate coroutine. So if you go and take a look on the documentation of this buffer, and you can just go through this documentation. If you read this documentation, you will understand it more clearly. It has mentioned and clearly over here that when or why we should use a buffer over here. Buffer flow emission value via a channel of a specific capacity, and by default is of 64, and runs collector in a separate set. So buffer and the collector runs on a separate coroutine. So this is on a separate coroutine. The collector is on a separate coroutine, and the buffer over there is on a separate coroutine. So you can see some example over here, which is printing in sequence ABC. It goes to 1A, 2A, right? 1A, 2A, 1A, 1B, 2B, 1C, 2C. So all of these are in sequence now. But if we use some the flow over here, so in the flow, the buffer over there, buffer between each and collect. So buffer operator creates a separate coroutine. During execution of the flow, it applies to the consider the following code. So here we can see that the operator creates a separate coroutine. So we saw already that it creates a separate coroutine for us, and it executes each code before the buffer. So we don't have to wait for the another 2 millisecond or 200 millisecond to get our code done. So I hope you guys got it. Just try to do some practice over there, write some code and try to practice it, and read the documentation. It has mentioned clearly that how does it actually works, like the buffer capacity, and all of those are already mentioned over here. And you can see the channel that conflict, and it has only channel that unlimited, channel that buffered, so it has some capacity. By default is 64. And I think that's all. So you just go and read the documentation and try to create your own example. Let's meet up on our next lecture. Till then, have a great day. Yeah, hi there, and welcome back. And let us continue with our lesson. And on the previous lecture, we saw about the buffer operator in Kotlin Flow. And in this lecture, we are going to learn about the conflict operator in Kotlin Flow. So let's take a look on the example. First of all, I'll just copy this same code over here and paste it below. And instead of the buffer, I'll just say conflat conflict. And I will just comment out this section because we are not going to use that one. And now instead of the buffer, what I will do is I'll say that's a conflict operator over there. We are using the same example over there. We are not changing anything, all of those. So if you haven't watched the previous lecture, just make sure you go and watch the previous lecture, because I have mentioned a lot of things on that lecture already. And what we will do now is we will just run our application, and we'll see what is the difference between the buffer operator and the conflict operator through the example. And if I go to the logcat, and you can see that the total time taken is completely different than the buffer. It's only taking around 1415 milliseconds. And you can see that some value is missing over here. So if one, it goes to the log 1, gets the 2 value and prints out for us. Log 2 and gets the 2, and 1 again, the 3 is missing, the 4 is there, 5 is missing, 6 is here, 7 is missing, and 8 is here, and 9 is missing again, and 10 is over there. So what actually it does is the conflict operator. Let's say you have some consumer is taking a lot of time to consume it, and the producer is over there, the flow that we are producing over here. We are producing a value of 1 to 10 over there. It has also some delay over there, and also has a delay on the consumer and the producer both sides. So which means that when there is some delay and your consumer is unable to consume at the speed of what the producer is producing. So this is a producer that is producing a value at a faster rate than the consumer can consume it. So we are consuming at the rate of 200 milliseconds, but it's producing at rate of the 1000 milliseconds. So this consumer, the flow that is emitting the value is faster than the one that we are collecting over here. It has to wait for the 200 millisecond to consume that particular value. So when that happens, what the conflict does is it will just discard any value that can discard the previous value, and you can just get the latest one. So it doesn't care of the previous one, it only cares about the latest one, what is going to be latest, and just get that particular what is the latest emitted value and just get that value and get for us. So it doesn't care about the sequence, or it doesn't care about the any value that it has to buffer. So in the buffer, it was buffering for us until and unless we are consuming it. It helps us to consume buffer that value. It helps us to buffer, and then when we consumer was ready, then it was able to print that value. So it was the case in the buffer. But now in case of the conflict, it doesn't care. So it only cares about the latest value. So if it can miss any of the values. So you can see that we get 1, 2, 3 is missing. So it doesn't care and only gets the latest one, which is a 4. And again 5 is missing, then only we get around the 6 one. And again we get only 7 is missing again, and then we only get the 8 value. So in this way, it doesn't care about the previous value, or it doesn't care how to buffer that particular value. So it just care about the latest value, what is get emitted, and if that is the time that we are collecting it, then it just give it to us. So if you go and read the documentation of the conflict over there, you can read the documentation over here. Yeah. Conflict flow emission by a conflicted channel and runs a collector in a separate coroutine. So which means that it still runs on the separate coroutine. This is done in a separate coroutine, and the collection is done in a separate coroutine. That's why it took a lot lesser time over here. It takes only 1415 milliseconds. That's and you can see the effect of this is that emitter is never suspended. So which means the emitter just continuously produce the value to a slow collector. So collector is over here, the consumer, which is a slow one. So this is a faster. It has a delay of 100, but it has a delay of 200. So which means our collector is slower over there. But the collector always gets the most recent emitted value. So it only gets the most recent emitted value. So you can just go and read all of those, the documentation. You will have some more understanding over there. And I hope you guys got it. So just go and practice. It's quite similar with the buffer, but buffer is help us to buffer whatever item is coming from the below over here, the flow, right? The producer is whatever producing, it help us to buffer. But the conflict doesn't buffer it. It only care of the latest value. So we'll meet up in the next lecture. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lesson. And in this lesson, we are going to learn about the collect latest operator. So in the previous, we have learned about the buffer and the conflict, and lastly, we will learn about the collect latest. So let us take a look on the example of that one. So first of all, I'll just copy the same block of code from here, just paste it below, and this one I will just comment it out, as we are not going to use that one anymore. And let us replace this one conflict operator with the collect the latest one. So we just collect the latest, and inside this collect latest, then I will just I don't need a collect. I will just delete that, copy this and paste it over there. Just remove this one. So I don't need that. I just need a collect latest. So it's quite similar with the conflict. So let us take a look of the example. So first of all, we'll run our code and we'll see the difference. So let me run the code for now, and let us go to the logcat, and you can see that log one is all printing the log one, and only comes to the last, which is of 10 over there. So whenever we are using the collect latest, it only get the latest value. It doesn't care of any other value. So you can see when we are using a collect latest, it only gets us the last value. You can see over here, the 10 over there. It's not interested on the previous value. If you are a bit confused over there, what we can do is we can just log some information over here, log.d, and just tag it, and we'll just say collecti and collecting the value. Let's say we are collecting some value over there, and the value is of the current one. Okay, so now if I run this one, we should see some interesting information over there.
and let us see. We are getting some information. So let us take a look at the log, okay, over here. So we are getting log 1 and collecting the value, right? And log 1 main, again it goes to the and collecting the value. So it's collecting the value, but it doesn't get the latest one. Whenever it's getting the next, whenever it's coming over there, the next value comes over there, right? So that is replaced already. And then finally on, then only we get the last value over there. So the last one is printed for us, rest is ignored already, because whenever it has to wait for the 200 second over here, 200 millisecond. At that time the another value is already come over there and it's already replaced over there, so it's nothing to print out over there. So when we have a delay, we are doing some tasks over there, it's waiting, and at that time all the value are coming out from here, the flow, right? It has the producer has a 100 millisecond time delay. So when it comes over there, it's collecting over there, but it has to wait for another 200 millisecond. So at that time another again value comes, so it is replaced over there, and again it has to wait for the another 200 millisecond, and then at that time the value is already replaced and replaced and replaced, and finally we only get the last value, that was the 10. And but now if we don't have any delay over here, then let us try to run, and at that time if we don't have delay, then it should get on the all of the values that we have. And you can see that it gets collecting the value and print out the 1, collecting the value 2 and print out the 2. So it gets all of the value, which means that when this is has a delay and this doesn't has any, this is performing some tasks, but here we are able to collect the latest one. But let's say we have some tasks and we are doing some filtering, or at that time the consumer is not able to collect the latest value, and that time it will ignore all of the previous values. So let's say if I go to the, if I have even around let's say if I have around 100. So if I go and run this one, let us take a look at the logcat. You can see the different values. So it's still able to print for us, you can see. So we're still able to collect the latest value. But if I have more time than this one, so it's producing at the 100 millisecond delay. But if we have around 120 millisecond delay, then we should miss some of the values, right? So we see that it's collecting, but it's not able to get that particular value because our consumer is a bit slow. It cannot collect the latest value, so the previous value is already discarded. So that's how it's actually working over there. And if you go to the documentation, and if I go to the documentation over there, you can see the terminal flow operator that collects the given flow with the approval action. The critical difference from the collect is that when the original flow emits the value, right? When the original flow emits the value, the action or the block of the previous value is cancelled. So which means that when we are collecting over here, whenever it's a new value is emitted, the previously emitted value is discarded, or you can see what it says is cancelled. So the previous value is cancelled and it doesn't reach to the consumer at all. So here we are not able to print it because it's already get cancelled when the new value is emitted from the flow. So we have a delay over there and it's waiting over there to print out for us, but here the flow already emits the second value and that value is already cancelled. So whenever the new value is emitted from here, the previous value get cancelled. So that's why we get the only latest one. So if our consumer has a delay, or it is taking more time than the producer to consume that particular value, then we are not going to get it. We will get only the latest one. So I hope you guys got it. Try to practice it and try to read the documentation and try to do some practice on the code, and you will be more familiar with it. So we already saw about the buffer, conflate, and this is collect latest. So we saw about the buffer and the conflate and then the collect latest. And the conflate and the collect latest is quite similar, and if you can differentiate, it's quite similar. But things over there is collect latest, we don't have to make use of the collect. So it has the collect latest already. And that's it for this lecture, and let's meet up in the next lecture. Till then, have a great day.
Yeah, hi there, and welcome back. And let us continue with our lesson. And in this section, we are going to learn about the zip operator in Kotlin Flow. So let us take a look and let us see by the example, and then I'll try to explain it. So first of all, I have created a lifecycle scope over here, and we have some helper class or helper method over here, which will generate a user list as well as a age list. So let me add some more of let's say 40 and of the 50, and also okay, so that should be okay. So we have a 5 users and a 5 age, so that should match. And let's go over here and let us create a val of the users, which is of equals to users list dot as flow. Let me convert to the flow, and val age, which is of equal to age list dot as flows. So we have a two flow over here, which is of user and age. Now let us try to combine. So zip operators help us to combine the emission of the both the flow together. So let's say we want to combine, or we want to zip these two flows together, then we can make use of a zip operator. So how do we make use of a zip operator? Is we can take any of these variable, any of the flow over here. So let us take as the users flow dot, I can make use of the zip operator over here, and I need to combine it with the another flow. So another flow that we have is a age. So now I can combine it, and then I can create a lambda expression over here, and I'll just say as first one is of the user and second one is of the age. So we have a two parameter over here, and now we have a user list as well as the age over here. So now what we will do is we will try to combine these two, and for that I'll just say user, and I'll get the $sign user, and dash I will get the age, and that is of the $sign age. So now I have combined the two flow over here. One is of user and the age, and then finally I'll just go and dot collect it, and then I can log the d and tag, and I'll just print out the it. Okay, so if I run this application, so let me try to run the application. And now when you see over here, we say we receive a user 1 and the age 10, and now we can see it has joined, or it has joined both of our, let's say we have joined our user and the age. So user 1 age is 10, user 2 age is of 20, and user 3 age is 30, user 4 age is of 40, and user 5 age is of 50. So if you go to let's go to the user and zip operator, and let's take a look on what does it actually says over here. It zips the value from the current flow and with the other flow, and provide the transform function applied to each pair of the value. The resulting flow completes as soon as one of the flows completes, and cancel its call on the remaining flows. So which means if as soon as one of these flows is complete, then the another or the remaining flows get cancelled. So how does we do that one is, let's say I have a 60 over here, and we only have a user of a 5, but we have a age list of the 60. So this 60 should not be called, and it should be cancelled. So if I run the application one more time, and if I go and take a look at the logcat, you can see that the 60 never prints out over here, because that is being cancelled over here. So it means that the resulting flow completes as soon as one of the flows completes. So if one of the flows completes, then the remaining flows get the cancel, or the cancel is called on the remaining flows. So zip operator is quite useful if you want to combine the two flow, and sometimes if you want to do a parallel network call, or if you want to do a parallel network call to the API and get the user as well as get the some of the other information at the same time, and at that time the zip operator is quite useful. So we can see that using a zip operator we can combine the two flow together, and I hope you guys can understand it. You can just go and read the documentation as well as try to make use of the code that we have written over here. So try to write it down yourself and try to practice more. So that's it for this lesson. We'll meet up in our next lecture. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lesson. And today we are going to learn about the combine operator. And on the previous lecture we learned about the zip operator, and the combine operator is the another operator which can be used to combine one or more flows. So let us go and take a look in the practical example how we can utilize this combine operator. So first of all, I'll create a val and I'll just say users, which is of equals to user list dot as flows, as flow. Okay, and we have another val ages, and which is of equals to age list, sorry, age list, right, dot as flow. Okay, so we have a two variable of users and age over here, and what we will do now is let us try to combine this using a combine operator. So I can use anyone, so I'll use a users dot combine, users dot combine, and you can see it takes another parameter of a flow. So I can pass the second as a age over here, and then I will make use of lambda expression, and I need to take a two variable over here. One is of user and the second one is of age. And okay, so once we have that one, now I can let us transform this one. So I can transform this one, and I will just say as a name, and that should be of the dollar user, and then let's have of the age. So I have an age of a dollar sign age, and then I can go dot collect it, right? And when I collect it, I can log that on log dot d, and that comma I will just combine it like let's say, okay, so the value, I'll just call it as a value and just pass the dollar sign and the it. Okay, so we have created two variable over here. One is of user, sorry, two flows, and one is of user and one is of age, and then we use a combine to combine these two, and two flow that we're combining, and then we just transform some value over here, and then we collect it. And if we try to run this one, we will let us go and run this one, and let us see the output, and then we'll try to explain it more a bit. So let's go to the logcat, and you can see we get a value as a name, and one, the first user is emitted, and which gets a value of 10, and this again we get a value of 1 over here, and which the output of age is of 20, and again we get a user 2, and then again the age 20. So what is happening over here is, first time when it get the output as 10 over here, the age 10, at that time the recent value that emitted by the user was the user 1. And when the age again emitted a value of 2, at that time the recent user was, or the most recent emitted value was the user 1. And then when the user 2 was emitted, at that time the most recent age was emitted, or was 20. And similarly, when the age 30 was emitted, the second flow when was emitted, the age was emitted, we had a recent value of the user of a user 2. That's why we get a 2. So it always takes the recent value, and other are discarded. So if we go and take a look at the combine operator, and let us try to read some documentation. And what does it actually say? Returns a flow whose value are generated with transform function, and combining
the most recently emitted value of each flows. So which means it takes a both, if you see it says a recently emitted value of each flow. So it takes a recently emitted value of both flows, not only the one. So in the zip operator it was taking only the one, and as soon as one of the flows get finished, then the another was get terminated, right? So that's the not case in the combine. In the combine it takes care of both the recently emitted value of the each flow. So it is working on the each flow, not only one. But in the zip operator it was only working on the one. So if once whether the user or whether the edge was the flow was finished, then the another flow was automatically get terminated or it was cancelled. So now let us take a bit more example. I'll just say val and I'll just say time, and which is of equal, so I'll just say system dot get the current time in millisecond, and now I want to log that time. So how much time was taken from the from all of those to complete. So let's say on each value was emitted and how much time it's taking. So value, and then I'll just create a time taken. So time taken, I will just say $, and system dot the current time millisecond minus the time that we previously recorded. If I run again, and let me go to the logcat over there, and let us check the logout. So 10, 20, 10, 11, 37. It's taking some time, so I think we will add some delay so it will be more easy for us to read. So what I will do is I will add a dot, and I will just say on each I will just delay delay, and I'll just say on the users I am putting a delay of 100 millisecond, and on this on each I'll just say delay, and I'll just put around 300 millisecond. That would be fine, I think. So now let us try to calculate all of those emitting value time. So how much the time is taking on each emitted value. So if I go to logcat, now I get a value name of a 1, and it took a 362 millisecond, which is like the first value is emitted over here 10, and when it came to the edge, so it has to wait around 300 millisecond plus, right? So the 300 millisecond, we took around 362 millisecond to get the first edge value and the user. So the when user came out and it was emitted, and then it had to wait for the first edge to emitted, which took around 300, and then plus the user, and which around 362 millisecond, and we get the user 1 and the edge 10. And after that you can see that the another 463 millisecond it took to get the second user. So 300 plus 100, we get a user 2. So it's emitting the continuously. So whenever we get the user, the second user is emitted, we again go and collect that value, and we get the recent age of 10. So recent age is the age of 10 because it has to wait another 300, which is of total 600 millisecond to get the age 20. So when it is waiting for another 300 millisecond, we get the another user 3 is emitted, because every 100 millisecond we are emitting the another user value, and at that time we get the user 3, and at that time the age is still 10 because it hasn't emitted the second value for the age. So it took around time 566 millisecond, and at that time we had the user 3 and the age is still 10. And then when we go to the 600 millisecond, 3 plus 3 is 6, so it totally 600 millisecond to emit the second value, so which get a 20. So at that time the recent user was user 3, right? So we get the correct user 3 and the age of 20. And after that immediately we get a user 4, because the next is of the user, the another 100 second another 100 millisecond we get another user. So we get the user 4, and at that time the age was still on 20, because it has to wait another 300 millisecond, which will be next value will be on the 900 millisecond. So on the 700 we still get the user 5, and then we get go to the 900 millisecond, where we get age of 30, and at that time the recent value was of the user was still 5, and then we get the user 5, and then we get now here after that we don't have any users, so we have already emitted all the users 1, 2, 3, 4, and 5. So now when there's still value left for the age, so in the previous zip operator it would terminate over here, it would not go to the next over here, because it will cancel the another flow as soon as one of the flow gets completed. But here you can see that the user 5 is still getting emitted, and then the age is still continuing to emit value. So when the age 30 was emitted, it was at 970 millisecond, and at that time we have a user of 5, and the recent value was 5, and when the age was 40 emitted at 900 plus another 300 is of 1200 millisecond, and at that time the recent user was still 5, and then on 12 plus another 300 we get a 1500, and at that time the age 50 was emitted, right, and still the user was the 5. So I hope you guys got it. Just try to go and practice it more and try to understand, and you will understand it better when you do it personally. So try to write a code of yourself and try to understand it, what it's actually doing, so you can add a delay and check the output. It will be more easy to understand. So let us continue with on our next lecture. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lesson. And today we are going to learn about the exception handling in Kotlin Flow. And there are basically two ways that we can do. One is through the imperative exception handling, and the next one is through the declarative exception handling. So let's go and take a look in a practical example how we can handle the exception. So let us try to understand through our practical code. First of all, I'll make use of a lifecycle, lifecycle scope. Let me launch the lifecycle scope over there. And now we have a coroutine scope over here, and I'll just say val ags is equals to ag list that we have dot as flow. So let me convert it to the flow, and then once we have edges, what I will do is I will just ags edges dot collect it, and now we have I can say I have an edge over there, and let me try to log this one, log the d and tag it. And now I can say value that we have each of the that we tell age. And if I try to run this one, we should get the printout of the age that we have from 10 to 50. So if I go to helper, we say 10 to 50. So I should go to logcat, and it should print all the emitted value for us. The next thing is that we want to do is we want to produce an error so we can test the exception handling. So I'll produce an error. So I'll just use a Kotlin function to check, and this check I have to check some condition. So if I go over here, it checks some condition over here, throws an illegal exception if the value is false. So if the value is false, then it will throw an exception. So we have to check, we have to make it false. So how do you make it false is if the age, let's say, is less than 50, the age that we have, so 10, 20, 30, 40, till 40 it should be, and till 40 it should be okay. So we don't have the false, we don't get the false condition, it is true. So the age is less than 50, right? So we should get a true condition, then that should not trigger us the exception. But once we reach the false value, so check if it is the value is false, then we should get the exception. So once it reaches the 50 is not less than the 50, so that is a false condition, then we should get an error. So I will use lambda expression, and on the lambda expression I'll just we can print out the error value over here. So I'll just say error over error that we are getting from here, and error, I will just say error on, let's say, value. So what value we get, and the value is of the age, I think, right? So age is the one that we are getting. Okay, so now if I run this one, I should get some error. So if you go over here, now let us wait for the app to. Okay, so now it throws some exception at the error on value 50. So when it reaches the value 50, we get an error, because till from 10 to 40 is true, condition is true. Once it reaches 50, condition becomes false, so we get that error. But if we take a look, the app is crashed over here, and if I run the application, it should crash our application. So the application got crashed because we are not handling the exception over there. So how do we handle the exception is we can make use of a try catch block. So try, this is an imperative way of handling the exception. Catch, let us catch it, and I'll just say E, and it should be exception from the Kotlin, and then we will log that error. Let's see, log.e, let's say E, for the error, and tag, and we will get it dot the, let's say, e dot to string. So let me convert it to a string, and now I can cut this section and paste it inside the try block. And this is an imperative way of handling. So let me run the application, and you should see that the application should not crash. Okay, so the application didn't crash, and if I go to logcat, we get the exception value here. And let's say now that this is on the collect. So this is a downstream, and the upstream is here. So upstream is over here where we can get the flow, but this is a collect, which we can consider as a downstream. So now let us say that we have some error over here. So how do we produce the error over there is, I can just say that map it. So let us try to map it, make use of a map, and over there I'll just say check the condition. So I'll just make use of the same condition and check it over here. Let's say the age, I will just say, and finally I will just emit that value. So not the iterator, I'll just emit the value of age over there. Okay, so now this is having some error over here. We are checking, and we are actually going to get some exception. And what we want to do is, let's say we have this kind of exception, then how are we going to handle it? So what I will do is, I'll just comment this section, right? So because we are not going to, we already saw on the downstream. Now this is upstream, and you can consider this is upstream because this is before we collect it. And now after we collect, this is downstream where our actual values goes to the consumer. So this is a consumer over there. So, and this is a producer. So now what we can do is, if I run my application, so let us take a look, and let me go to the logcat, and you can see it still handles the error without any crashing our app. So which means that the try catch block over here can handle both the exception from the producer as well as from the consumer. So upstream is over here, which we can say as a producer, and the downstream we can call it as a consumer. So we are having an error over here, as well as we had an error over here. Now we have commented out and implemented that over there. So which means that the try catch, or the imperative way of exception handling, can handle both the upstream and downstream error in an easy way. So let us take a look on the declarative way. So let me create a lifecycle scope over here, and launch the coroutine scope over here, and I think I'll comment out this one, so I'm not going to use that one for now. And let me just copy this section and paste it over here. I'll just remove the map for now, and I just have a flow over there. And now what we have to do is I have to make use of this one. I'll just copy this section and just paste this below, and let's say on collect. And now on collect I will check this condition. Right, so I'll check this condition over here, and this should be of the age. I'm just doing the same thing. I'm checking it out over there, and then I'll just log the age over there. Now if I run my application, let me run my application, and let me go to the logcat, and should see that it exception occurred and our app just got crashed. So how do we handle it declarative way is now I can make use of the catch option over there. So the catch options should be before the collect. So over here I can catch all of the errors, and how do I get that? Is log the t. I think I'll just copy from the same from here and just paste it over there, and it should be let's say error is of e. Okay, so we get the same. And now let us see that we have catched the error on a declarative way. And now let us run the application, and let me go to the logcat, and it should, okay, so we still got the app crashed. I think so app got crashed. So let me take a look where I did it wrong. So okay, so here it still is there, so this should be removed, right? So it should not be over there, so I need to remove this one. So I'll just remove this one, and I need to put it on the top. So I'll just go over there. Let me just let me remove all of those, right? So this is the one that I need to remove, and here is the one. Let me arrange it properly. So log should be over here. Okay, let me arrange it properly, and on the top one I'll just copy from here. So I'll just use the same map option. Okay, so now I have a similar option over like here. So you can consider this is a producer of upstream is producing some error, and on the downstream, right, downstream we are catching that error before the collect. So before collect we are catching it, and we are logging it. So let us try to run this one, and if I go to the logcat, now it should be fine and it should catch the error for us, and the application didn't crash. But what will happen if we have some like a previous one? So if I comment this one, if I comment out this one, and now if I have some error over here on the collect or the downstream, which is of collect, and let's say if I have an error over there, what will happen? So if I have, and I think you saw previously that the application crashed and we were unable to catch that particular exception. If I go and check at the logcat, now you can see there is an exception and it crashed our application. So it didn't catch the error that was on our downstream or on the collect. So the consumer, whenever there was an error on the consumer side, it did not catch it, but the producer error, it was able to catch it. So how do we catch the error that is on the collect or the consumer side? So here we can make use of the on each operation. So let us make use of the on each. So I'll just as.on each, and this is a suspending function. So if I go to on each, this is a flow.extension function, returns a flow which perform a given action on each value of the original flow. So on the each value we want to perform some action over there. On each, we will just cut this section and paste it over here. We on the each value that we are receiving, which is, let's say we are receiving an age value, and there we are checking some condition. So we are checking this one, and if the error is there, it will catch that, throw that error. And on each, which means that we have a flow and it is emitting a each value, and we are checking on that each value. And after that each value, what we will do is we will catch that one after that. So this is another way that we can actually check. So let me try to run the application. Okay, so I think I have error, so I still need to remove this one. Now I don't need this one because okay, so I don't need that one, right? So I don't need to do that one, and I can do that one in here. So on each, I will just log that one. So log the value on each, check it and log it, right, over there. Okay, so now I can run this one. It should print out the same as the previously, but it can handle the error properly. So here can handle the error properly because now we have make use of the on each, and on each flow emitted value we are checking some condition and then logging it, and then we are just collecting it. So on the collect, we are not using any lambda expression to get that particular value or check that value or log it. So we just move it to check, so on each, and then we check the condition over there. So this is another way that we can handle a declarative way or the imperative way of exception handling in Kotlin. So you can just use both one, and this is just the extension function. To if you go to the catch over here, just take a look. This is an extension function on the Kotlin Flow, and you can just go and read through the documentation over there. Catch the exception of the flow completion and cause a specific action with the caught exception. This operator is a transparent to the exception that occurs in downstream flow and does not catch the exception that are thrown to cancel the flow. So this is another way that we can actually make use of the declarative as well as of the imperative exception handling. So I hope you guys got it, and so let's meet up in the next lecture. Till then, have a great day.
Yeah, hi there, and welcome back, and let us continue with our lesson. And in this section we are going to take a look on the flat map concat operator, and I think we have already taken a look on the map operator and as well as the transform operator. And let us take a look on the flat map concat operator and how it is different than the map operator. So let us go and get started. First of all, I'll just make use of, let's say, age list that we have dot as flow, and dot on each I will make use, and I'll just delay to 100 millisecond, and dot I will just make use of a map operator first, and later we'll change it to the flat map concat. So map, and let's say I want to call it to the another function, or let's say I want to call it to the another flow over here. So that should be of the user list dot as flow. So we have a user list dot as flow dot let us try to map it or transform it, anything that you can use. And here I will concatenate, let's say I want to concatenate with the age. So I have a age variable over here, and here I get as a user. So age and the user we have. Now I will try to say that the user, which is of the $user, and the another one is of the age that we have, and I'll just say the age, sorry, $age. So now we get over there, and I'll just try to dot collect it over here. And now when you collect it, you can see it gets the object. So object as a flow of the string. So if I try to log .d, and I'll just say tag comma, let's say whatever I'm getting it is the flow of string, which is an object. So I have to convert it to, let's say, to a string, right? And now if I run my application, and we'll try to see what is the log
we are getting? We are getting the object of the flow of the string. So let's try to go to the logcat, and now you can see that when it print out something different for us. We cannot understand that, right? So we have to change that one. So now let us try to make use of flatten this. Let us try to flatten this flat map concat. So I'll try to use of the flat map concat, and this still in the Kotlin Flow preview. So we have to make use of the add flow preview annotation on create method. So which means that is still in the uh, preview mode, and I think it's not suitable for to make use in the production environment, but you can just try to learn it. And I'll just add that one. And now what we will do is I'll just try to run my application again, and we will see the logcat now for now. And let us take a look at the logcat. So now you can see we flatten that particular object and get the value of from there. So what is the difference? So we saw that map was actually giving us whatever was coming from this flow. So it was getting the object of the flow of string, and we were getting the same thing whenever we are collecting. So the same object was passing down to our collect over here. But now when I make use of the flat map here, it transforms the operator. So whatever we are getting from here, it flattens it. So we are getting the object, and it flattens it as the string. So we get as the value of the particular object. So that is a particular difference between the map and the flat map. We can see with using the map we get the whole object, right, the flow of the string. But here when we use of the flat map, we can flatten that particular flow and get the each of those value. And let us try to also put some let me try to delay it. So let's say I want to make delay over here, and let's say about the 400, and we'll see the time consumption above there. So and I'll just go and say about here the time, and the time is particularly let's say SYST system dot, sorry, it should be of the $sign SYS system dot the current millisecond dot minus. I don't have, okay, so I need to add the particular value as the start time, which is of equals system dot current time in millisecond. Now I can set as a string, it should be time, or I can just say start time. So start time, we get it from here, and I'll just minus it, and then we should get the value. And now if I run this one, let us try to run, and let us try to get look at our, yeah. So now we get our first printout over here, the log. Okay, I think let it finish first, then we will take a look. Okay, so I think it's done already. So the first user we get, right, so username we get, and age is of 10. So age is the first that we are getting. So from here we are getting the age from the first flow, and the first one is a 400 plus 100 millisecond, which is a 500 millisecond. Then after that it will print for us this one. Okay, so we got that one. And then again we saw that it is printing it is taking the flow from our second flow over here, which is of the user. So it gets the user 1 2 3 4 5, and at that time we only had the first emit from our first flow over here, which was of the age 10. And you can see that the first was the 500 and second is the 400. Every 400 millisecond after that it is emitting the value of the user. So after it complete all of the 1 2 3 4 5, and then it again go back to from the first flow, we get the value of 20, age is of 20, and this is time millisecond, and we get the user 1. And then again from it comes to the second flow, and it is again emitting all the value from this user, and then again it will go back to the first flow, which is after that it will get the age of 30. So here we are getting each flow on the first, and then again we are going to the second flow over there, and after it's complete, the second flow gets completed, then again it moves back to the first flow over here. So this is how the sequence is happening over here. So try to practice it in your own, and just make sure that when we use a map, if we use a map over here, because we have a second flow over here, if we use a map over here, we will just get the object of the flow over here. So whatever is the flow is emitting, we'll just get the flow of that particular object. But if you want to flatten and get the particular value, we have to make use of the flat map or the flat map concat, and there are other operators too that we will take a look on our coming lecture. So that's it for this lesson. Just go and practice this. We will meet up in the next lecture. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lesson. And in this section we are going to learn about the flat map merge, and in the previous lesson we learned about the flat map concat. And let us take a look on the flat map merge. So what I will do is I'll just copy all of those. Okay, so I'll just copy the same example from here and just paste it below over here, and then I'll just change the flat map concat to flat map merge. Okay, so I think that should be the one, and rest of the things we will keep as of the flat map concat, so later it's easy for us to understand. And next is what I will do is I'll just change the age, first of all age, and then I'll change it to the user. So first age and then user. So I'll just copy the same thing and replace it over here. That should be fine, because the age is emitting the first value, so first flow is emitting the age. And if I try to run this one, and let us try to run, and let us see the output that we get from this one. So let me go to the logcat, and okay, so let us take a look. So now we have some output over here. The age 10, the first age 10 emitted on the 100 millisecond, and then it had to go to the second flow over here and had to wait for another 400 delay. So 400 plus 1 is 500 millisecond of delay, and then we got our first output over here, the first emitted value around 600 millisecond, right? So we got the age of 10 and then user 1. But here you see we have to, on the second flow of the user list, we have a delay of 400, so which means that the execution is halted for the another 400 seconds. So at that time we can still go back to our first flow, which is of age, and then emit the rest of the value on each 100 millisecond of delay. So here you can see it had to wait for the another 400 millisecond. At that time we went to the age and we got our second flow of 20, 30 and 40. So 1, 2, 3, 4, another 400 milliseconds. So at that time we emitted another 4 values over there, right? So 7, 8, 9 and then 10, and you see the user 2 had come out on the after that. So after waiting of another 400 millisecond, it had to wait for another 400 seconds to emit the second user from this flow. At that time we went to the first flow of the age and emitted the another 4 value, because waiting time is 400. At that time we can emit the another 400 and another 4 value from this flow, which is of age list, because it has a 100 millisecond of delay. So you can see the user first, the second user came out after the 400 second of delay from the first. So 6 plus another 4 is around 1000, right? So at that time again, after second value of emitted of the user, we have to wait another 400. So at that time we go to the again on the first, and then get other rest of the values. So like we got a 20, 30, 40, right? Age of, so for the same user. And after the 400 millisecond, you can see around 14,000 milliseconds something, we got the third user. So at that time we have to emit another, at the waiting time of another 400 milliseconds, we can go and get of the other users. So age of the age 50 for the users 20, because here we have only for the 40 for the age 40 for the user 2, we still have age 50 for the user 2, so we got this one. And then we get the 20, 30, 40 for the user 3, and at that time of we got of age 40, we had a time for the another emitted value of the user 4, and then we had to wait another 400 milliseconds, and then again we went and emitted rest of the values from here. So it's working sequentially as well as the concurrently. So everything is on the sequence as well as the concurrent. So when there is a delay, we can go back and get some of the values from our first flow. So we don't have to wait for the sequence to complete. We still can do concurrently because there is some delay. So we can go back to our first edge over here, edge flow, and then we can get back the other remaining value at the remaining time of 400. So this is how the flat map merge is working over here. But if we take a look on the previous, which was a flat map concat, what it does is it first emitted value over here and comes out the user list and delay for 400, and then we get the first emitted value and then wait for another 400 milliseconds, then we get the second user, and then we wait for another 400, we get the another user. So all of the user must be completed over here. So this has to be done sequentially, and then move on to the second age value over here, and then come over here and emit the each value for that one. So it was everything doing sequentially because we have to wait for the user list to emit all of the values, then only we can move on to the second emitted value from our age. And after that, the next value of age is completed, then again it had to emit all of the values for the user list, and then only we can move back to our first flow over here. So that was on the flat map concat. But here in the flat map merge, we have a different like it can do sequentially as well as the concurrently, because when there is a delay, we can go back to our first age flow and get the remaining value. So if you take a look on the documentation, you can see over here, like this operator calls the transform sequentially, and we can see already it has a sequence as well as the merge the resulting both flow with the concurrency. So there is also a concurrency. It works both sequentially as well as the concurrency over there, and the limit on the number of concurrently called flows. We can also limit the concurrently called. By default, I think it's around 16. The default concurrency property is I think around 16, right? So you can just go through the documentation, and you can also take note that even though this operator looks familiar, we discourage it usage in a regular application specific flow. It's not recommended. It is discouraged its usage in the regular application specific flow. But sometimes we have some requirement, like we have to flatten, and we need to flatten our flows, or we have some requirement, then we can still use it, but it's always not recommended to use it in a regular application specific flow. And I think that's all, and you can just go and practice, and then you can get it more familiar, because it's quite it may be first of all, it may be quite difficult for you to understand what it's actually trying to do, but when you try to practice it more, you can get the more concept and how it is working and how it is different from our flat map concat. You can get it along when you try to practice more. So just try practice more, and let's meet up on our next lecture. Till then, have a great day. Hi there, and welcome back, and let us continue with our lesson. And in this section, we are going to learn about the flat map latest. And we have already taken a look on the flat map concat as well as the flat map merge. And let us take a look on the flat map latest and how it's different from our previous two other flat map operators. So let's go back, and I'll just copy the same code over from here. So I don't have to rewrite all of those, and I also don't have to explain, because everything we have already explained our previous two videos. So I'll just change it, the flat map to the flat map latest, and then the delay, I think I'll just change it to 500. Right, so I've changed that one to 500, and then I will run my application. So let us wait for the application to come up, and then I'll go to the logcat over here, and we'll see that we are getting age 50. User 1, user 2 is also age 50, user 3 also 50, 4 and 5 all get the age of 50 only. So other remaining like 10, 20, 30, 40 are missing. So how does it actually happens over there is the flat map latest only takes the latest value for us. So from the first over here, which is over here, the first edge flow, which is emitting value on the 100 millisecond delay, and then when it comes to the user listed flow, and the second flow over here, and then it has to wait for another 500 millisecond, and at that waiting time it goes and takes all of the value over here from here, and when it's reached over here it has to again wait, right? So it is discarded, and again it goes back and again get the second value, which is of age 20, and then it again come over here and it has to wait for another 500 millisecond, so it discarded that value. So every time it's coming over here, irritating and emitting all of those values, only the latest value. So when it is reach around the 500 millisecond, and now it can emit this value. So you can see around 1000 millisecond, right? So here it has to wait for 500, and here on each we have to emit 5 values, which takes around 100 into 5 is 500 milliseconds. So 500 plus 500 is around 1000 millisecond to emit the first value of user 1. And when the user 1 is emitted, it gets only the latest value from our age list or as age flow over there. So it takes only the age flow, so from the latest value. So the previous value, whenever it has to come to the user list, we have to wait for another 500 millisecond. At that time, the first value or the previously emitted value is discarded or cancelled. And if you go and take a look on the flat map latest, you can see that when the original flow emits the new value, so the original flow, so which is the age, right, age list as flows, emits the first new value, the previous flow produced by the transform block is cancelled. So previous flow produced by the transform block is cancelled. So whenever it reaches over here, this is transform block, it cancels our previous flow. So that's why we don't get any printout over there. But let's say if I want to print out that value, so if I copy this and paste it over here, we actually can see that particular value. So I'll just remove this section, and I just want to show you that there is a printout, or I have to make it a log, not the image. So I'll just paste it over there and just cut this section. I'll just paste it over here. So I just want to show you guys that actually we are receiving that age value over there. And let me try to run this one, and let us run it, and let's wait for the application to come. So you can see that we have the printout over there. So you can see the age 10, 20, 30, 40 up to 50 is coming over here, right? So only when it is delayed, then it gets cancelled. So here after 500 milliseconds, then our first user is output or emitted, right? So at that time we only had the latest value of 50. So on the waiting time of 500, we have already emitted all of the values, and the latest value is 50. That's why we get only the latest value of the 50. So here you can see it's still 50, here is 50, here is 50, here is 50, because the latest value is already 50 and rest of the value are discarded or been cancelled. So that's all for the flat map latest, and maybe a bit confusing for you guys to understand, but if you practice more and if you try to implement some of the application, then you will be more comfortable with it. So just practice it, and we'll meet up on our next lecture. Till then, have a great day. Hi there, and welcome back, and let us continue with our lesson. And this is a new section, and in this section we are actually going to utilize whatever we have learned in our previous section. So in the previous section we learned about the Kotlin Flow API, and in this section we are going to utilize it in our actual Android application. So we'll be using with the Room API as well as with the Retrofit API. So how to make all of those network calls, and how to insert the data, retrieve the data from our API as well as from our local database. So we'll be using the API in our application, and let us take a look about the application. This is a base application that I'm providing to you. This is a ready-made application which has already implemented all of those stuff. It is a working application, and we'll just modify this application to utilize a Flow API in this application. So let us try to run our current application, and let us see what is the application actually doing, and we'll try to understand what are the things that we'll be modifying. So if I go to my device, you can see the application is over there, and if I try to log in, so dem1@gmail.com, and I'll just 1 2 3 4 5 6 7 8. So you can just sign up and create your own account. That's fine, and this is already connected to the API. So I'll just log in, and you can see that we have a list of the tasks that we get from the API. So we'll modify this one to make use with the Flow API, and also the add task is there. We'll make use this one to insert the data to our local DB, and as well as to retrieve the data using the Flow API. And this is a working application, and you just have to import this project. I will attach this project to the course lecture, and you just have to download and import in your Android Studio. And I hope you guys can do that one. And after you import, you just run the application, and it should look like the same, and everything should work fine. And if you have an error when you are importing or the application is crashing, just let me know, because we'll be using this application to modify, and the application should be in the working condition. So before you watch the next lecture, just make sure that your application is working fine without any crash, or you have successfully imported the application to your Android Studio. And let us take a look on the project structure. So this is, if you go to the app, we have a Java section, and I'll go to the top level, which is a com.day1.todo package over here. And on the model section, we have some of the models like local and the remote and the repository. So this is making use of the MVVM architecture, and I hope you guys are already familiar with the MVVM architecture. And here, and then we have a util section, which has some of the utilities class and the helper classes for us to make use in our application. And on the view, we have an adapter as well as the UI. And on the UI, we have all of the fragments, and the activities are on this UI package. And let us go to the view model. So this is a view model, and it contains the view model for all of our fragment as well as for the activities. So each fragment and the activities has its own view model over here. So this is making use of the MVVM architecture, and I hope you guys are already familiar. And make sure before you start this one, you are familiar with the previous section, which is a Kotlin Flow as well as the Kotlin coroutines. And if you are not familiar, this will be very difficult for you to understand. So this is an already ready-made application, because I am not going to create from the scratch. So if you are not familiar with the coroutine or the Kotlin Flow, then you may get lost. So make sure you complete before this section, the first section, as well as you must have the basic concept about the Kotlin coroutines. And these are all the layouts, so I'll not go into that one. You can just go and take a look. And then we will go and take a look on the build.gradle on the module, the app. So here I have already implemented all of the dependencies, like the retrofit version, coroutine, and also like we have the database section over here, which is of the room. So all of those plugins or the dependencies has already been implemented over here. So you don't have to go and do everything. And all of those dependencies version are already implemented over here. So if the new version is there, you just have to change it over here. So this is a project structure, basic project structure. You can just go and take a look on it, and you can just try to open some of the classes like the DAO or the database. Just try to understand the code. But basically, we are not going to change much of the code. We are only going to make a use of the Kotlin Flow in this project. So I haven't implemented any of the Kotlin Flow over here. So we'll just replacing the Kotlin coroutine suspend function with our flow function. So let us meet up in our next lecture, and till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lesson. So what we will do now is, since our application is actually working, and what we need to do is we need to build something. So let's say we want to modify, the first thing is we want to modify this. Okay, so the loading screen. So this is our splash activity. So we need to find that splash activity. So just go to the view model section and go to this splash, and there we will find a splash view model. So we'll have to modify this one to make use with the Kotlin Flow API. And as well as go to the view and go to the UI package, and there we have a splash package over here, and open that splash activity. So we also need to modify this one, and then we need to go to the model package and go to the repository, and then open the validate token repository, because this is the one that it is actually working over here, calling that validate token. So we need to modify all of this, and rest of the things I think we don't have to modify. And before we start, let us open the util package. So we have a util package, and in the result set we need to add something. Let us open the result set, and here we will create a object. So object of loading, and this should be of the return type is of result set, and result set of, let's say, nothing. I think so, nothing should be. And okay, so now we have a result set. So this result set is a shell class. We will be using it to like for our state, like it is a loading state, or whether it's a success state, or whether it is an error state. So we will make use of this one to actually notify our UI section, like whether it is loading, and when it is of loading we want to show a loading screen. When it has a success, then we want to show the success data, and when it has an error we want to show the error message. So this is a shell class, and just open the result set class, shell class, on the util package, and modify or add this one new line of code, which is of object loading and result set, and return nothing. So type is of nothing. Just close this one. And next is we will modify the repository. So what we will do is I'll just comment out this one. Just comment out this one, and then just copy the function name and just paste it over here. And now here we have a return type. So flow, return type is a flow, and then this is of the result set, result result set. So make sure you take from our package, don't take from the java.sql. We need our result set, and result set type, let's say, of the string. So why I'm taking string is if I go to this particular return type of the response validate token, and the validate token has the response of the validate response, and if you go over here we have a message which is of type of string. So that's why I'm taking the string over there. Okay, so this network service is actually the one that is the retrofit service over here, interface, that is calling all of the endpoint. So you can just go through and see all of the endpoint that actually is calling, and I hope you guys are already familiar and with the retrofit instance and how to create all of this stuff. So we will just go and call that function. So the return type is a flow, and after that we have to create a flow builder. So I hope you are already familiar. So we'll create a flow builder, and then I'll just emit the first value from here. So emit, and the result set dot the loading. So whenever we are calling API, we have to return the first of all is the loading state. Comment out this one, and then I'll just go and create a try catch block over here. Try and catch it of the exception, and whenever there is an exception, we will emit the result set of the error and pass the error over here, or the exception. Now inside here I'll just create a val and res bun response, which is equals to we have to call this one network service dot validate token, call to the API and get the response. And then when we have a response, I can check if the response is success or not. If it is successful, and if it is successful, then we will emit the success message. If there is an error, then we have to respond the error message. So we have to emit the message over here, and here we will emit the success. So result set dot success, right? And the success is I need to get the response message. So response dot the body, and if it is not null, dot get the message, and that should return or the emit the response message. On the error side, we have some more thing to do, and I think that I can take from the task repository. There is already a response error handling, so I'll just copy this code and just paste it over here. And I think I need to close the bracket. Okay. So just go to the task repository. There is already one code to handle the response code. So error response. So whenever there is whenever there is an unauthorized, we will be returning this one. And whenever there is a bad request error, then we will return this error message. And not found page, so we'll return this one. So based on the error code, we are actually returning some message or the emitting some message based on the error code. So when the response code, we check the response we get, and the code is of this one. I think that you should be familiar with all of those already. And then so I think our validate token method in our repository is should be fine. We are returning the flow and emitting the each value based on the condition. So first we have a loading, and then if it is success or if it is failure, or there is some exception. And I'll go to the splash view model over here, and in the splash view model we have to modify the code. So I'll just I think I'll just copy this one and just comment out this one. We are not going to use that one, and I'll just paste the code below over here. And we are not returning the live data, just remove the live data from there. And then over here I'll make use of the view model scope. So vi view model scope dot, I will launch a new coroutine scope based on the view model scope. So the view model scope can let's say if we are using a coroutine scope, then we have to manually destroy it. But if we use a view model scope, then whenever our view model is destroyed, then all of the coroutine scope running on this scope will be destroyed whenever our view model is destroyed. So that prevents the memory leak, and that should be fine. So we have our coroutine scope. Now we can actually call this function. So first of all, I will just make use of a try catch block over here. So if any error, we can catch it. So exception, Kotlin exception, and then I'll just make use of the timber dot log it, timber dot d, and I'll just say e. Okay, so it should be of the e, and pass the exception. Inside here we will check for condition first. If the network helper dot is network connected, and this will actually check whether there is a network connection or not. So if there is a network connection, or else if there is no network connection, we want to do something. So here we need to pass the context. So I have a private val context over here, and then the context is over here. The app context equals to application. So application comes from here. So create a variable of the private val context and add this context over there, and then I can pass this context over to here. So if you don't have this context, just create it. So when you first time open, maybe you don't have that context. So if you don't have, just add that context over there. So this is private val context and the context, and then pass that context over here. So now we have a network connection, and I'll just say val. Okay, so instead of val, I'll just call that function which is of this one. So just cut this section and paste it. So I need to call the repository.validate token, right? And this is a flow, return type is flow. I can just flow on, and I'll just call it as a dispatcher.the IO thread. because since this is a long running task, I want to do in the background, different thread than the main thread. So we are on a different thread now. That, and I'll collect on the main thread. Collect it. So we'll collect it over here, and then we get the result set. So this is of the result, 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 and now I can make use of our, not the when, it should be when, and pass the result over here. So if the result is of the result set, result set, result set, and dot, if it is of the loading, then we want to actually show the loading screen. And if just copy this one instead of typing, just copy and paste it. We need a 3, so one is of the success, right, and one is of the error. Okay, so we need some variable to actually populate the information. So I'll go on the top over here and create some variable. So first of all, let's create a val of the progress, and this should be of a mutable live data, and let's say it is of the boolean, and which is of equals to mutable live data. And then I'll just duplicate this line, and this should be of the, let's say, token RESPO and token response, RESPO and SC token response, and this should be of the string type. And we also have to be error, so it should be of the error MSG message, and let's say of the int type first of all. So this should be of the int, and then let's duplicate the another one. This should be MSG string. So this is of string type. Okay, so we created a 4 variable over here. Just create this 4 variable, and based on the result, so I'll just say the progress, progress dot the value, which is of equals to, I'll just make it as a true. And here we'll just say we have our response, right? RESPO and response token response dot value. We'll pass that the result dot, we get the data dot toString. Convert this to string, and then I will just set that one to false. And here we will check for some condition. So if the let's say the result dot error, so if the error or the exception is not equals to, let's say, null, so if that is not null, then we want to show the error message string dot the value, error message string dot the value, right? So value, which is of equals to, we will say the result dot the error, and get the message. And if that is false, so if the error exception is not there, then we will just go and make use of the let's say error message. So error message int dot the value, and which is of equals to result dot the error message, which is of integer type, so we'll just pass that one. Okay, so that should be fine now, and I will just have to remove this section, right? So I'll just remove that one, and on the if there is no internet, I'll just log it, and I'll just call that timber.d, and I'll just say that no YNTR internet CONNEC connection, right? Okay, so we have actually filled this one, so validate token, Now our view model is ready, and we need to go to this splash activity. And since this is okay, so we need to modify all of this. So check network, everything we have to modify. So what we will do now is I think I'll go and create a new function. Just create a new function on here, and I'll just call it as a private val, and I'll just say validate validate token function, and sorry, private function at the token token. So validate the token. And now what we need to do is we just have to actually call this function. So we have this function, right, suspending function, so we need to call this function. And for that, I think I will observe, we need to observe the, where is it, do we have any observer? Okay, so currently we don't have any observer, so let us observe the actual value. So based on here, so if the value, okay, so let me go to the view model. So if the value is of the, if the token is of the true, then we actually can show the based on over here. If we go over here, if the valid token is true, then we have to start the main activity, and if it is not, then we have to say that we have to start the login activity. So for that, what we'll do over here is validate token. I will just observe first private val and obser we are okay, so it should be not the val function. Let's say obser we are as observers, and here we will observe our live data. So whatever live data we have a progress and we have a response. All of those we will observe this. So first of all, let us observe this one, and also let us observe the token. So token is the one. So first of all, let us take a token, and in the token I'll just token, okay, so view model dot token, we need to observe the token dot observe, and the life cycle is of this comma, and we create a observer over here, and we will say if the value is of empty, is null or empty. So if it is null or empty, then we know that the token is not set. So if it is the token is not set, then we have to go to the login screen. So I'll just copy this, and I know that the token is not set, or this is the first time the application is installed, or maybe the application got uninstalled and got reinstalled. So I need to check the token. So if the token is null or empty, then we go to the login activity directly. And second is of the view model dot we have a token response. So we will take a token response over there, and we will see that, let's say if the token response, we'll observe this observe and this comma and the observer, and if we will check the condition, if it dot is null or empty. So if it is null or empty, again the response is of null or empty, then again we have to go to the login activity, and else we will check over there if the it value is of equals to true, so which means that we are actually, that is valid token. So the API will return true if the token is valid, and else, right, so we have, so if it is valid, then we will go to this particular activity. So I'll just finish the current activity and go to the main activity over there, and this one for the else condition. Okay, so I will just comment out this one, so we don't need that one anymore. Okay, and then I think I don't need this one too, this function, so I'm just using the observer over here, and this observer I can actually call from onCreate. So whenever there is onCreate, I'll that call the observer method. So I can just comment obsgr observe the live data, observe the live data over there, and then on not the on restart, I'll just remove that one and call the on resume. So whenever the application get resume, I want to just validate the token. So I'll just call the view model dot validate the token for us. So now I think we have replaced almost all of the code, and it should be fine. So if you try to go and run the application, it should be working fine. Let us wait for the application to come up. Now you can see that the loading screen was fine and we did not have any error, and it loaded for us, and successfully we were able to navigate to the main activity. So now let us try to uninstall the application and let us try to test it out. So if I uninstall my application and let us try to reinstall the application, then we should be able to go to the login screen. So if I go over here, now it should check for the login. So we are going to the login screen, and then I will just log in like a demo1@gmail.com and password 1234567 and let me log in. So now we can see it's working fine, and again if I restart the application, and that should work fine. So we get the loading screen. Okay, then we come to the main activity. So which means that our code here, which we make use of the flow, right, was working, or it's working fine. So we just changed everything from our Kotlin suspend function to we have a flow over here. So we utilize the flow over here, how to get a request and the response from the API. So this was the first section that we modified, was first of our splash activity. And the second, we will modify our let's say we will modify our another data, so where we get insert the tags. So if you go over here, we have add tags. We will modify this one to insert the data to our local database. So let's meet up in the next lecture. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lesson. And for this section, I would like you guys to give a small assignment, and that is to show this alert dialog whenever there is no internet connection. So this will show an alert dialog whenever there is no internet connection. The function is already there, so you just have to implement so when to show this particular dialog. And in the splash view model, we have already checked for the network connection over here. So whenever there is no network connection, you just have to show this particular alert dialog. So this is assignment for you guys. Just go and do it on your own, and if you cannot do, that's fine, and I will give you a solution on the next lecture. So till then, good luck, and I'll see you in the next video. Till then, have a great day. Hi there, and welcome back, and let us continue with our section. So this is a solution for the previous assignment, and I hope you guys can do it. But if you were not able to do it, that's fine. Let us take a look on how we can accomplish that one. So first of all, I'll go and create a new live data over here. Just duplicate this one, and I'll just say each no network. Okay, each network connect is network connected. So this is a boolean variable of the live data that we have. And when I had this one, I'll just go and implement it over here and just say that value each of equals to false. So which means that whenever the value changes to false, that means there is no internet connection. And since we have this live data, now we can just go to the splash activity and observe that particular live data. So on the top, I'll just go and view model dot each network connected and dot observe this one, current observer, and let's create observer over there, and I'll just say if and boolean. So this is a boolean. If not, or we'll just call it as a if not if not true, right? Then we will just go and call that function, which is of show alert dialog. And I think that should be fine. And now let me open my activity and let me try to disable the internet connection. So let me disable the internet connection or the network connection. If I try to run my application, and let us take a look if we are able to show that particular show alert dialog over here. And let us wait. And yeah, it should be sorry, there is no network connection, please check your network connection. That's fine. So that was good, and if you were able to do it, that's fine, and you may be able to do it in a different way, that's still fine. So this should be private and function, and that should be fine. Okay, so this was the solution for your assignment, and I hope you guys were able to do it. So let's meet up on our next lecture. Till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lesson. And in this section, we are going to learn about the Kotlin Flow with the Room API. So we'll be inserting data to our local database and then retrieving the data back from our Room database. So let us take a look on how to do it in our current application. So first of all, I'll go to the model, and then I will go to the local. So I will take a look on the DAO, and I have one DAO which is of a tax, and here we have an insert operator. So this is a suspend function, and it takes a tax entity, and return type is of the long, so which will give the current insert record ID. So if I go to tax entity, these are the entities that the field that we have in our database. So we need to fill this one. So after that, I will go to the view model, and there is a tax, and in the tax I will go to the tax view model. So this is the view model that we have to adjust, and then I will go to the view, and on the view I have the tax, so tax fragment. And then I have another one which is on the repository. So let us go to the repository over there, and we have add, it should be of the tax repository. Is it the one? Yeah. So we'll be utilizing all of this. So tax repository, currently it is actually inserting a data to the API first, and then inserting it to the local DB, but we will modify this one to insert the data first to our local database, and we will see how the flow works on the inserting and retrieving the data from our local DB. And then I think I'll just, first of all, we'll go and customize this tax repository. So in the tax repository, what we have to do is, on the tax DAO, we don't have to change anything. So we don't have to currently change anything over here in the insert function over here. And we just have to go to the tax repository, just open this class, which is of tax repository. And here, I think here what we did, okay, so add tax. So I think not this one. So I think, sorry, this one. It should be not this one. It should be add tax. So this is the one, because we have to add a tax from here. So this is the one. So currently you can see this is sending the request to the API, where it is adding the tax. And what we will do is we will just copy the same function, right? Just copy it, and then I'll just comment out this one for now. And then I will just go down and create a new function over here. So let us create a suspend function of add tax to DB. So add tax to the DB. And if you go to the application, because this is currently sending the request to the API, so this is making use of this function and it's sending the whatever we are adding, it's directly adding to the API instead of our local DB. So we'll modify it to add to the local DB. So over here, and then this should return a flow, right? So it should be the return type of the flow, and it should be of the result set. Where is that one? Result set. result set. Why it's not coming? RESULT. So result set is over here, and the return type is of the long. So why long? Because the return type from here is a long, so that's why we are taking the type of the result set as the long. And then equals to, we need a flow builder over here. So we have a flow builder, and then inside this, first thing that we have to do is emit the result set dot the loading. So first of all, anything is we have to load. And then I'll create a try catch block over here, try catch and en exception over here, and then whenever we have, we will emit that one. So emit it and emit the result set dot the error and pass the particular exception over there. And here what we have to do is we need to add that to the local DB. So val result, which is of equals to, I need to add not the network service also. I need another service that is of the database service. So private val, so app database. So I need the app database to access the database. So app database, just import that, just add this variable, and app database dot, hey, what happened? App database dot the DAO, we have the tax DAO dot insert, and here we need to insert the tax entity. So I can remove this one, and here I need to pass the parameter as a tax entity, and this tax entity over here, tax entity, and I don't need a token, so I can remove that one. And then I'll pass that tax entity over here, right? So we have a result, and then we can emit that particular result. Result dot not the result dot, it should be result set, right? Dot, we have a success over here, and then we pass the result over there. Okay, so we have add tax function ready, which is making use of the flow. So now we have a flow over here, and on the tax tab we did not change anything. Now we will go to the tax view model, and in the tax view model what we have to do is we have to change. So what we are going to change is we'll just copy this one, and then I'll comment out this one, and then I'll paste the value over here. So what we will do is I will create add tax to DB function name, right? And instead of the add tax, I need a tax entity over here. So the tax entity. So we have a tax entity, and we don't need the live data. I can remove the live data from there. And over here I have to create a view model scope dot launcher. View model scope dot launch a new coroutine scope, and in this coroutine scope I'm going to call that, okay, so add tax repository dot add tax to DB and pass the tax entity over there. So pass the tax entity over there, and then what I can do is I can just say flow on. So I need to run that one on dispatcher dot the IO thread, right? run on the dispatcher thread dot collect it. So now we get the RESUL result, right? And then if we check the if is the result set. If the result set dot is loading, then we have to do something. Then we can just copy the same thing. Okay, sorry, I forgot. It should be when the result, and then inside I have this one. Wait, sometimes I make a mistake over there. It's because I'm talking and typing at the same time, so sometimes my brain may be confusing. That's it. So it's really difficult to talk at the same time and type at the same time. So success and then error. Yeah. Okay, so now we have a when condition to check all of those stuff, right? And then we have, okay, so progress value is there. So I just can take the progress value. So whenever it's a loading, then we have to show the progress. And then when this one is gone, I'll just say false. When there is an error, I'll just say the progress value is to false, as well as on the success, I'll just set it to false. And then I have each success value. So each success value is there. So I also need to set this one. Each success value, right? So each success value. So just copy over, paste it over here. Dot, sorry, is equals to result dot, and we pass the data dot to a string. So we get the latest result from the currently inserted value. So is success, okay, is success dot value. Is success is what is it? Okay, is success is a boolean. So is success is not this one. So I just need to is success is a. I have to pass it as a true because we have a true over there. Sorry for that. Okay, so when we get the result, let us try to log that one. timber.d and resu result dot, we get the data, right, dot to string. So just try to log that one. And then when we have error, we can just set the progress value to false, and then we can just say each error. So we have each error over here. So each error value is there. Each error, let us set this one to is equals to result, right? We have a result dot and error. So over here, result dot error dot to string. So let us pass it to string. Okay, that's it. So I can remove this block from here now. So now we have a Kotlin Flow over here. We have implemented the Kotlin Flow, and then when we have this one, we can just implement this one in our. So let us go. Okay, so we have some error here. So we need to pass the app database. So how do we pass the app database over there? Is we need to pass the second parameter, which is a app database. So app database dot get instance, and I need to pass the context. So context, I can pass the application. So this application is from here. So I think that should be fine. Okay, so the error is gone. And now we'll go to the task fragment. So in the task fragment, what we have to do is we need, let us go and take a look what we have over here. So progress is already there, each error is already there, and next is the is success, right? So is success need to be there. So view model dot is why the is success is not there. So if I go to task view model, is success is private, so I need to make it public. And then is success dot observe, and owner is of this, right? Or it should be of the, since this is a fragment, I have to make use of the view lifecycle owner, comma, and this is a observer. Okay, and then we check if the success is true, or we just say if true. If it is true, then we'll just show the where is the issue success dialog. So if it is true, so we are setting here as true, right? Then we will show the success dialog over here. Success dialog is over here, tasks added successfully. So we have set up this one. So next is to add the tasks. So how do we add the tasks? Is currently we don't have to observe this one. So let me comment out this one, or copy this one first of all, and let me comment out this one, and then I will just go and paste it over here. Add tasks to DB. So let us add the tasks to the DB, and here I need a task entity. So I have to pass the task entity. So this is a task entity, and then what I have to do is just view model dot add task to DB and pass the task entity over there. And then when the prepare task is called, we are preparing all of the value from the text box. So the value is taken from the text box over here, and then I'll just comment out this one as well as this one. Now I need to prepare and create the task entity over there. So how do we create a task entity is just go over here and val, just say task entity, which is of equals to task entity. And first of all, I need to pass the task ID. So task ID, I think currently what we have is, if I go to the database inspector, and let us take a look on the current database. So okay, so let us go to the task entity, and we will see that the task ID is of 39. So we have to add the task entity is 39 to 40, right? And then after the task entity, we have the title, which is of title, and then we have a body, which is a body, and then after body we have a note that we can pass, then the note is the one, and we have a status, which is the status that we have, and then we have the user ID. So user ID, which is of this give of 2, and we have a created, and we need some string as well as for, then we have a updated at, which is of the string. So these are the requirements that we have to pass. The title, body, note, and status comes from here, and other we are adding manually, because later we have to get it from the API and insert it to the local DB. But for now we just want to add locally first, that's why we have to create all of those. So let's say create a 2020, let's create a date 12/28, and let's have a time of the 0, let's say 00, 00, and 00. So let us create a date and time. Okay, now this task entity I can pass to add task to DB and pass the task entity over there. Okay, I think that should be fine. So everything should be, I think, fine. So we don't have to change, I think, other. So we just create it and observe the success. Okay, that's fine. So let us try to run now, run our application, and let us try to add a record. And we also have to monitor the database. So let us try to run the application first. And the application got installed, and we'll go to the add tasks section over here. And then I'll try to add, let's say, test title 1, and this is test 1, and let's give a started note for test 1. I'll just try to add. Okay, the tax was added successfully. So now if I go and take a look at the database inspector and let me try to refresh the table, and you can see the current one has been inserted over here, right? So we have inserted over there, which means that the current flow that to insert our record is currently working fine. So this is the flow that we have created, will insert for us, right? And everything is working over here fine. Now let us try to retrieve the data from our DB. So the next is from here, tags. If you go to the tags down, here we have get all tags from the DB. So let us try to, after we insert it, so let us observe that particular whatever is inserted, and whenever there is a new insertion, let us retrieve the data back from the database. So when there is some changes in the DB table, we want to retrieve back. So this is something like live data. So when something changes, we get back the latest value back from the database. So how do we do that? Is I'll just copy this section, and just paste it over here, and I'll remove the suspend function because we'll make use of the flow over here. So when we are using the flow, we don't have to create a suspend function, right? So that flow already has a suspend function already, so we don't have to add the okay. So and get all ducks from DB, and I'll just rename it as a flow. So this return type is a flow and list of the tax entity. So we have this function created over here, and let us go back to our repository over here, and let us create a one function. So function, and I'll just say get all tags from DB. So this should get all the tags from the DB, and it should return the app database dot tags down that get all tags from DB, and we use the flow. So currently we are using the flow. If you go over here, we are getting as a flow value. And now since we have this one, let us try to implement that one in our view model. So let's go to the tags view model. And currently we don't have a place to show that after we insert it, but let us try to log it. So we will see in the logcat after we insert it, we should get back all of the value that we have inserted. So how do we do that? Is over here I'll create a one private function, because private I don't want to call it from the activity, and function, and I'll just take the same name. So just take the same name from here. And here we have make a view model scope dot launch the view model scope, and I have the, after that I'll just make use of the app tags repository dot get all tags from the DB. So since this is flow on, I have to make sure dispatcher.io, and then dot I will just collect it. So collect it, and we get the result over here. So result, and since we have a result, so what I will do is I will try to log that particular result. So what we can do is or else we can assign it to the list. Currently we don't have any list, so I think I'll just say result dot for each. So I think not this one, not the for loop. So result dot for each. Let us try to take a list, and this is a tax. Now since we have a tax, I've just log that particular tax timber.d, and we have a tax.toString. So I'm not doing anything because of this. We are not going to call, or we don't want to populate over here. So we don't have any place to populate. Otherwise we can show it in our recycle view, but currently we just want to show that how we can get the data back from our DB. So we want to see that the live view. So when we insert it, we have to get back the live data. So we don't have to call the get the task from the DB function again and again. So it should be automatically done for us. So this function I'll just call from the here. So on the init block, I'll just call that function, right? So currently we are not calling from the activity. And if I go, okay, so I think that should be fine. And let us try to run our application. And let us wait for the application to come. And the application is running, and what we will do is we'll try to add some tasks, and we'll go to the logcat over here, right? And I think this should be the one, not the verb words, it should be debug. Just clear it out. Let us try to add, so this should be test title 2. Okay, I think I have to change that particular value. So when we are adding the task fragment, this is of the 40, so I have to make it to the 41 because I need to increment that particular task ID. So sorry for that one, I need to rerun the application because I need to change the task ID, because if there is a duplicate, then it cannot come on to the top because I'm filtering it by the task ID. So the latest will be shown on the top. So I need to amend it to the 41 to make it the latest or the last value that was inserted. So I'll just go and try to insert a new record from here. Test title 2 and the, let's say the test body 2, sorry, body 2, and pending to start it, and test note 2. And now let me clear it out and I'll insert this one. Okay, so when we insert it, you can see that the value is written for us. So you can see the latest value should be here, right? 41, the task ID. This is the one that we currently inserted. So we don't have to call that function again and again. So we don't have to call the get task from the DB or the view model, the get task from DB again and again whenever we are inserting or updating or changing anything in our current task table. So the flow will observe that particular the flow will observe that particular table, and whenever there is some changes on that, and it will give the latest changes back to the UI. So this way you can see that we have make use of the flow over here. That's why we make use of a flow. So if we make use of a flow over here, then this table or this query can be executed whenever there is new changes. So whenever we insert or delete or update, and this flow will actually go and execute this query for us. So we don't have to call this function in again and again. So that's it for this lecture. Hope you understood that how to make use the Kotlin Flow with the RoomDB. So we saw how to insert it as well as how to retrieve the data using the Kotlin Flow option. So that's all, and we'll meet up in the next lecture. Try to practice it, and till then, have a great day. Yeah, hi there, and welcome back, and let us continue with our lesson. And in this lesson, we are going to cover up, okay, so if you go to the home over here, home screen, and we have a list of the to do, and this is we need to fetch it from the API. So there are a lot of process involved over here. First thing is that we have to get the latest record from our local DB, and using that latest record ID we have to fetch the new record from the API. So we are only fetching the new record from the API, and then when we get that particular response, we have to insert it to the local DB, and from that local DB we again fetch back all of these records. So there are few processes involved over here, so we need to accomplish it using a flow. So let us go and take a look how we can accomplish that one using a flow. So first of all, I'll go to the home fragment. This is the one that we need, and another one is of the home view model that we are going to make a use, and also the task repository, and then the task DAO. So here I think we don't have to modify currently anything in the tags DAO, but let's go to the tags repository. And here if you see that we have a get tags by ID, that is the one that we need. And first thing is the get max. So this is the get max record ID. So we need to get the latest record ID from our DB. So get max record ID or the tags ID. Select max record ID from the tags entity. So which means we are getting the maximum or the latest record ID from our tags table. And using that we need to fetch it from the API. So here and here, and if I go to the home view model, and if I go somewhere here, so get max ID from DB. So if I go over here, you can see that this is the one that is calling the tags repository dot get max ID. So let us first of all customize this one, and I will go to the tags repository, and over here we need to return a flow. So I hope you guys can actually do it by now, and if you can do it, that's really great. And here I need to create a flow builder, right? And okay, we have a flow builder, and when we have a flow we don't have to return it. And then first of all we will just emit the result set dot the loading. So we want to show the loading result over there. And then over here we have to emit this value of the result set the success, and then here we have to emit the result set that error. I think that should be the one. Okay, so we have modified this function to get the max ID using the Kotlin Flow. And if I go to the home view model, now we get an error over here. Okay, so now we have okay, so it's already in the launch view model scope.launch. I can just remove this dispatcher.main since the launch is already in the main thread. And then, or else I think I'll just copy this whole function and create a new one, and then we will modify that one. So if anything goes wrong, then we can still revert it back. So I'll just, okay, I need to comment out this block. So let me comment out. Okay, and now we have a new function which is of a get, right? So okay, so here get the max ID from DB, and then here I don't need the launch, so let me remove the dispatcher.main since the launch already is in the main thread. And then here I think we don't need this one to I don't need this one. Okay, so let it be there. So first of all we'll just go and we need to call this function. So this is the one that we need to call. Just call this function, right? And then dot flow on, and we have to run in the which thread. So I will just make you share the dispatcher.io thread, and that I will just collect it. And when we collect it, we have our result set over here. I will just result, and then I can make use of our when condition. So I think you should be already familiar with this. So I just pass the result over here, and then we can just check the condition. I think here, if result set the success, just copy this, and here. So we need a 3 success, loading, and the error. So this should be of the loading, this is success, and this is of error. And when there is a loading, then I can show the value. Okay, so is there a progress bar? So here is a progress, so I can show that actually progress there when it is loading. Progress dot the value, which is equals to, I can say true. And on here in the error, I will just go and say it as false. And then what we have, I think, where is that one? Okay, so max record ID, I need to post that one. So what we will do is get task by ID. This is calling this function, right? So where is that function? I need to check that function. Okay, so I think I'll just remove this one. So get task by ID, this is actually calling the another function, so which is calling the API. Okay, so I need to call this function. Just copy this, and on success I need to call that one. So okay, let me arrange it properly, and I think I'll just use a single line comment instead of the multi-line comment over there. And here I need to pass the result dot the data that we are getting dot to string. Okay, that should be fine. So we are actually getting and calling that function from here when it is success, right? And then I think I can move it over here. And then another thing that we have done is the here the max record ID. I need to post it. So just copy the comment and make it as a single line comment over there, and then I'll just copy this code and here paste it. What happened? Okay, so instead of the max ID that I post, I'll use a value, and then I will just say equals to, this should be of the data that we are getting, so it should be result set that data that to a string. Okay, so we should be good there, right? And then if you have an error, then I can just copy this section and paste it over here, same code. And other thing, I think that should be fine. I think if you want to get this one, I can just paste it over here, so you can just check the running thread. And other thing, I think I can remove it. So just remove this, all of this section, we are not going to use it. Okay, so I think that should be fine. So here we get the max ID from the DB, and it is a flow. We collect we flow on the IO thread and then collect the result, and based on the result set that we are actually doing showing the filling the data. And the next step is to get task by ID. So get task by ID is calling get task by ID, so in the task repository. And if I go to the get task by ID, so we are passing token and the max ID from here, so token and the max ID, right? So we need to modify this code. So first of all, I'll just go, and here the return type is result set, so we have to flow, and here in the flow we have the result set of the task list of task entity. Then this should be of, I need to create a flow builder. So when you have a flow builder, I can emit the value of the loading result set result result set, right, without the loading. So now we can see that there is a loading, and then we get we call to the API passing the token and the max ID. If I go to the retrofit service over there, it's calling this particular endpoint passing the max ID, and we are getting the response as the list of the task response. So here we get the response and we check whether it is success, and if the success, then we map it to the task response over here and create a task entity as a list, and then we have to return. So instead of return, I have to create a emit. So okay, so it should be of the emit the value of the result set the success over there. And then what I had to do is here, instead of return, I need to call the emit when, right, and just close the bracket over here. So emit the error, and then instead of return I have to emit it over here too. Okay, so I think that's this function should be ready. So if you go and check, we are first emitting the results at that loading, and then we are getting the response, calling the API, getting the response, check for the success. If success, then we emit the success result, and if error, then we emit the result, error result over there. And if I go to the home view model now, I need to modify this one. So here we already have a coroutine scope, since we have already launched a view model scope and calling that get task by function from this coroutine scope already, view model scope. So we just have to make use of our coroutine scope over here, and then what we have to do is we have to check for the network connection over here. So after we check the network connection, then I can just remove this code over here, and then I can call this function. So if there is a network connection, then we'll call this function. Let's call this function, and since this is a flow, I can say turn the flow on, and just call this one in dispatcher.io thread, and then I will just collect it collect it, and then we get the result here, right? It should be result result. Okay, since we have a result, now I can make use of a when condition, and I will pass the result over here, and then I think you should be already familiar with this one. And then result set, I can each a result set, right? And each a result set, and I have to make use of I think 3. So one is of the loading, one is of success, and one is of the error, right? So we have a 3. Okay, and then what it's actually doing is then we get this one data. If it is okay, first of all it's in the loading, so I just have to pass the loading value. So progress, and progress should be of the true, and then if it is error, then I have to say that this is of the false. And in success, if it was success, then we can just copy this code from there and just paste it in the success section. So here we get the result, the data as convert it to the cast it to the list of anything, and we have a data. So if data is not null, then we are going to check whether if this list is of the filter is the instance of the task entity. Whether it's the instance of the task entity, then we create a task entity, and then when we call the insert many. So here we are actually calling the insert many. So for that, if I go to this function insert many, so here it is calling insert many, and in the task DAO we are calling this function, so insert many. So we need to modify that one too, and then I think rest of the thing is after that we call this function to get the task from the. So after insert is successful, then we are actually calling this function get the task from the DB. So that should be of this one. We also need to modify. Okay, so I think we already have that one over here, right? And I think I can remove this section for now. No, I think I don't need it anymore. Okay, and if there is no internet connection, so I need to close that bracket over here. Sorry, close the bracket, and I need to check if there is no internet connection, right? And if there is no internet connection, then what we have to do is I'll just log timber.d and just say no network connection found. for you in the no network connection form. And then I will call this function, get the task from the DB. So if there is no internet, we will just get the record from the local DB. And just single line comment and just copy and paste this one. Get the task from the local DB if there is no internet connection. So I think that should be fine, and we need to modify this function, which is of task repository dot insert menu. And I think it should be fine. So if you want to create a separate function for this one, that should be fine. But I think I will leave it to you guys. So I think it should be fine. So we are just checking the data over here and filtering out. So if it's the instance of this one, and then if it is one, then we are just inserting it in as a list. So if I go over here, it is inserting as a list of the task entity. So that should be fine, I think, for me. And the next step is to get tasks from the DB. So if I go over here, get tasks from the DB, so we need to convert this one to the flow. So it is calling get all tasks from the DB. That's if I go to get all tasks from the DB, this is the one it's calling. So I think instead of calling this one, what you can do is you can just go to the tasks now, and you can see that get all tasks from the DB. So what we can do is actually we can just make use of the flow and watch the as the observable over here, and watch this particular table, and whenever there is a new change, then it will automatically pull for us. So for that, you can just make use of the previous function that we actually have already created, which is over this one. So this is the one that we have already created in the previous section, and I think we can use that one over there. So for that, I think I'll just copy the code from here. So this is the code, I think. Just copy this one and go over here and just paste it just below this one. Get all tasks from the DBS. I think it should be DB, and that should be the fine. And I can just say flow flow. So we are returning as a flow, and from the home view model, we can call that function. So this is also a coroutine scope, okay, and then okay over here. So I need to call this function. So task repository, right? Just make use of a try catch in case of the error. Exception, sorry, it should be of the exception that we have. Okay, and then just call that function dot get all tasks from DB as a flow, and the flow on dispatcher dot io, and then it should be dot collect. So I think you guys are already familiar with it. RESULT result we have, and then I think this is just we are just getting a list of the task entity, so we don't have to check for the result or anything. So if we check over here, so I can just pass that one to the task list from DB value. So task list from DB dot the value, which is of equals to the result. Since you can see the result is the list of task entities, so I can just directly pass it over here. And I think that should be the one. Another thing, I think we don't have to do anything over there. So we just collect it, and when we collect it, we just update our task list from DB. This is a list, I think. So if I go on the top, so task list from DB, yeah, this is a list of the task entity, and that should be fine. So I can just remove this section, or you can just comment it out if you want to check it out later. So just comment it out, that one, and on this one I'll just log the error. I think it should be E, right? remove that one. Okay, and I think that should be all that we have to do. And let us try to run our application. So let me run the application, and let us see if we have any error. So let's wait for the application to come up. Okay, so the application is up, and yeah, it's loading. Okay, so we get the list of the record already. That's working fine. And only thing is that the progress dialog over here is not dismissing. So for that we need to check I think in the home view model here. So at the end of, so I need to dismiss that one particularly. So I need to progress, set it to false somewhere over here. I think get task by ID. Yeah, I think after everything is completed, then I think I need to dismiss it, because here we are not dismissing it. Yeah, I think I will dismiss it over here. Progress value dot value equals to false. And if I rerun the application, and let us take a look, I think that should be the one. And let us take a look. Okay, so so it's fine. So I think that's all for this lesson. It's quite long already. So we'll meet up in the next lecture, and we still have some work to be done over here. And let's meet up in the next lecture. Till then, have a great day. Hi there, and welcome back. So let us continue with our lesson. So our home fragment, or the home screen, is already ready. And the next thing is that to add a task. On the previous, I think few previous lecture, we have modified this one. And if I go to the task, I can go to the task view model, and here we are actually inserting it to the local DB. But now what we need to do is we have to actually send the request to the API to insert in the API label. And then if I go over here, when we insert it, it should be inserted into the remote API, and then we will insert it to the local DB when we are actually fetching it from the home screen. So that is the concept over here. The first over here is send all of the task detail to the API and insert it over there. And then when we are in the home, we will fetch that record and insert it to our local DB. So how do we do that one is we have to modify this. So I will just comment out this code. So we are not going to use this code, and I'll just comment out this one too. So I need to modify this code. So the previous one, which is of to send the request to the API. So if I go to the add task repository, so add task repository over here, and that is this one. So I will just comment out all of those for now. And then what we will do is here, so I need this function, and here what we will do is we need a return type of the, I think I'll just copy from here, return type of the flow, right? Okay, I think I'll just make it as a return type of the flow. And then this is a flow of the result set. We need a result res result set, and the result set type, I think we can check from here what is the type it is returning. It's add task response. So add task response is the, if you go over here, this is the one it's returning. So what we will actually do is from here, if I go to the add task repository, here if I go to the task view model, I think task view model, here we are actually just checking whether it's success or the failure. So if it is success, the value is we will just say, so the success, which is of true or false. So we just need a true or the false over here. So we need a boolean. So for that I will go to the add task repository, and over here we just need a boolean value, and then it should be of the flow builder. Okay, so first we will just emit the result set the loading, right? As you know, we just need loading, and we need a try catch block in case we have of the error. And after that, what we have to do is I will just emit the value of the result set dot error and pass the exception over there. And then I can call this function, and that's the val respons, val response, response, and then call this one. So add tags, and this will return the response of the add tags response. And okay, so where I am here. So when I have the response, I can check for now if, and if the condition is if the response, right, response dot is successful, which means then it is successful, then I will just emit the success, emit the result set the success over here, and success of I'll just give it as a true. So we just need to return a true or false, that's why I'm just setting as a true, which means success. And else we have to catch the error. So I think we already have the error somewhere, so I think I'll just copy the error code from add tags response. No, where is that one? So some view model over here, home view model. I'll just copy, not the home view model, sorry, here. Let me copy the whole code from here and paste it on the add tags repository. Okay, so here we have actually make the use of the flow over there, flow builder, and then we are emitting the loading first, and then try catch block, right? So first of all we get the response, we send the response to the add tags and check whether if it was successful, and if successful we just emit the value as the true, and if it is false then we go and emit the error code. So I think that should be fine. So add tags, now I need to go to the tags view model and I need to modify my code over here. So first of all I'll make use of the view model scope that I will launch the new scope over here, and then I'll call this function, just call this function over here, and dot flow on, since this is a flow, and the dispatcher dot the IO thread, and then collect, since this is our result set, I need to get the result, and okay, so this is a mistake. So okay, result, then when we have a result we have a when condition and check for the result, and here we can check for the result of the is result set dot the loading, if it is loading, and so I'll just copy the same code and paste it over here. So here it should be of the success, and here it should be of the error, right? And then we can just say the success value, so it's emitting the value of success value is, sorry, it should be here in success. Success is equals to result dot the data dot to, okay, result dot data is it's coming as the any as boolean. Okay. And then after that we have a progress value, right? So we have a progress value need to be set it to the true, and here we will set it to false, and on the error the progress should be also false, and I think we can catch some error. This is the one error, each error, and I'll pass it over here, each error, and it should be of the result dot the error dot to string. Okay, so I think that should be fine, and I can just remove this section. Yeah. Okay, so we have, and this should not be of the live data. We don't need a live data there. And then I will go to the task fragment. Right, so since our this function is ready already, add task. So I will go to the task fragment over here, and over there add task to DB. So I'll just comment out this one. We are not using this one. We don't want to add to the local DB. We want to send the task to the API. So this is the one that we have to make a call. So we don't need all of those. We just have to call the function of the view model dot add the task and pass this one, add task. So we just have that one, and here I don't need all of those. I'll just comment out in case you need this one. I need this one. So I just create an add task and just call that particular function over there, and just remove this, all of those. And here we don't need this one. I just need to show the success dialog and the unsuccess dialog. So for that, what we will do is we will be observing the live data. So is success, so if it is true, then we are showing the success dialog, and else part, if it is returned false, then we will show the unsuccessful dialog. Just show that success or the unsuccess dialog based on the true or false condition from over here. So if it is true, then we will show the success dialog. If it is false, then we will show the unsuccessful dialog. I think that's all that we have to modify from here, and I think that should be the one. So if I run my application and let us try to add a new record. So let me run the application, and if I go to the device, let us try to add a new record over here, and let us see whether we have any error. And let us try to add a task. So I'll just go to add a task, and let me say test title 1, and just give a test body 1, and okay, what just happened? So it should be test 1 title and test 1 body, and depending, I'll just get started, and I'll just say not test 1. Okay, let us try to add this one, and the task added successfully. And if I go back to the home screen, and let us try to say if, okay, so we get a, which means that the task was successfully added to our API, and we get back. So I think that should be fine over here. And the next thing that we can do is if I go to the home view model, and here we are actually getting a task from the DB. So I think we don't need, if I go over here, so this is actually calling the get the flow. So I think we don't need a flow over here, depend on actually your requirement, but I think currently we don't need either flow, because whenever I go to the home screen over here, and that will refresh the actually layout and fetch the record from the API and insert it to the DB, then we are actually getting it back. So I think we don't need a flow over there. So I think I will convert it back to the suspend function that we previously used to do. So I'll just create a one function, and I think this is the one, right? So I think that should be, we can use that one. And I think I will just return a flow from here, and let me create a flow. Return type is of a flow, and that should create a flow builder, flow builder. And by now you should all be familiar with all of the steps. So first we will emit the value of the result set that the loading, and then after that we can make use of our try catch block over there and here. So I will just emit the value of result set that error, and here we just emit the value again of the result set of success. And let us go back to the view model, home view model, and here, so I can remove this section, get all tasks from DB. So I think I'll just remove this one, right? And here, so get all tasks from DB, flow on this one, and collect. So result we have, and in result I need to check the when condition, and when condition of the result, and that's of the is the result set dot is of the loading. Then I can show the loading screen, and I'll just copy this section and paste it 3 times. So here is of the success, and here is of the error. So just copy this and just a progress value and just show it to the true right here, and here we need to set it to the false, and here also we need to set it to the false, and I need to set the tags this one. So just copy this one and paste it over here. So this is a result set, so I need to convert it to the tags. So I think I just remove the previous value. So what I need to do is I think I need to get that back value instead of retyping everything here, and which is the one here. So result set, I need to get this one, right? Just copy. Yeah, so everything I should bring back. Okay, and then I'll just paste this one over here. Okay, that should be fine. And after setting everything, then only I'll dismiss the process dialog. And then I think I should remove this one. Okay, that's it. So if I try to run my application again, and let us see that whether the current get tags from DB is working. So let us wait for the application to come up. And here you can see, okay, so everything is working, and let us try to add a new record, and I'll say test2 title, and the body is test2 body, and depending I'll just get completed and not test2. Okay, just add this one. Okay, tasks added successfully, and now if I go back to the home, I should get that one. And that's great. So I think everything is working perfectly, and we don't have any error. And then the next thing is that there are other lot of stuff in this actually application. You can just go and modify it your own, and there you can delete the tags. You can always and edit the tags. So there are a lot of things that you can still do, and you can just go and practice with this project to implement the flow on all of those stuff. So we still have a profile section over here. I will leave it to you guys, so just go and practice with this project and you will be more familiar with it. So that's it, I think, and hopefully we'll meet up in the next lecture, and until then, have a great day. Yeah, hi there, and welcome back. So in this section I have a small assignment for you guys. So you can just go to the edit tags fragment over here. So go to the tags and go to the edit tags fragment, and what we have to do is we have to modify this one. So if you go to the edit tags fragment and then go to the view model over here, view model, and go to the edit tags view model, and then open the another one is the edit tags repository. So you can see here edit tags is sending to the API, and then we have another one is to the local database.
So if you go to the edit tags view model, we have edit tags over here, which is sending actually the tags, the edited tags to the API. And then when we receive a success over here, and then we are actually editing our local DB over here. So first we are sending the request to the API to update our tags, and then after we successfully receive the updated tags, then we again update the local DB over here. So your assignment over here is to modify all of this process using the Kotlin Flow. And by now you should be able to do it. So I give you an assignment over here and just try to do it. And we'll meet up in the next lecture where I will show you the solution for this one. So just try it on your own, and let's meet up in the next lecture. Till then, have a great day. Yeah, hi there, and welcome back. So let us continue, and let's take a solution for our previous assignment, where I asked you to perform or apply the flow to our current edit tags over here. So we'll go to the edit tags repository first of all, and okay, so what we will do is over here, you can see it get the response of the edit tags, and then we are calling this function. So what we will do now is we will return a flow. So I'll just say, first of all, let's try to go to the edit tags function in the retrofit API over here. Its return type is response of the edit tags response. And what I'll do is I'll go to the edit tags, and here we will say the return type. Okay, so here it should be flow, and in the flow, let me try to import that one flow from the coroutine flow. Okay, and this should be of the, not the response, it should be the result set that we have, right? Result set of the edit tags response. Okay, and then we'll create a flow builder over here. And then first thing that we will is emit the value of the result set dot loading, and after that we will make our try catch block over here of the exception E as the okay, so E as the exception, and then we will emit the value over here as the result set of the error, and error is of the exception that we can pass. And then I'll call this function inside the val and respon and response, which is of this one. So we get the response over here, and now we can emit the value of the result set that's success. Okay, so I need to check first if the response dot is successful, right? And then or the else part, we have to report the error or the emit the error. So here we can just emit the result set dot success, and in success we have to pass the response dot the body, and when you see in the body we have all of the body created and all of the record we have. So let us try to pass the body over there, and here we will, I think I'll just copy from somewhere here. I think we already have that one. We can just emit the same value, just copy this and just paste it over here. Okay, I think that should be fine for now. All right, let me try to readjust or format a little bit over here, and return type is of the flow. Okay, I think that should be a bit better. And then what we will try to do is, okay, so this one is currently done. And the next is we also need the update tags. So for the update tags, what we need is we will return the type is of the flow, and it should be of the result set. And the type, let me go to the update, and what is returning is returning the integer type. So I will just say the return type is of the int over here, and then we'll just build the flow builder over here, and first emit the value of the result set dot is loading, right? And then we'll use a try catch block, try and the catch over there, and e as a exception, and then we will just emit the exception of the result set dot the error and pass the exception over there. And I will call this one val result of equals to this one. When we get the result, we will just emit the value of the result. And why it is giving an error? Okay, so not the result, so it should be result set dot success and the result that we pass over here. Okay, that should be fine. So our edit tags repository is should be fine, right? And the next is we will go to the view model, so edit tags view model. So first of all, we will amend the edit tags. So here I'll just create a view model scope. That is a good practice. View model scope dot launch the coroutines scope. And when we launch the coroutines scope, we will first check for the internet connection. So if network helper class we have dot is network connected, and we need to pass the context. So currently, is there a context? So I think we don't have a context. So let me create a context over here. Private val, let's say context, and the type is of the context. And here I'll just create assign that context is of the application. Okay, so we have the context now, and here I will pass the context. Okay, so we have check for the internet connection, and we have the else part where there is no internet connection. Timber.tim timber.debug. Then I'll just say no network CONNEC connection found. Okay, so here now we have internet connection. We can actually go and call this function. So I'll just call the edit tags, and here we have to pass this particular value, so token and all of those. I'll just copy this and just paste it inside. Okay, so we call that one, and then since this dot flow on, and on the flow on I'll just say the dispatcher dot the IO thread. Then I'll just collect that particular, and we have the result set. So result result, sult result, and when I have a result, then I can make Sophie when condition and pass the result to check over here, right? So here then we just say each a result 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 set. I think I took the wrong one. Just import the result set from our to app result set dot loading, and if it is loading, then I want to show the loading, and just copy the same and paste it over here. So it should be loading success, and here we have of the error. Okay, so when we have a success, we just have to call this function, right? and here pass it that function, and here we have each loading, I think, or loading, is it the loading? So loading dot the value, so this is a progress bar. Loading dot value equals to true, and this loading should be false on here, and as well as on the error. So here update task, so we are just getting the, I'll just say as the result dot the data we are getting. And what does it says? It says is require a edit task response. So I'll just say as edit task response, and then here, and we have any error, so we have an error, right? So each error, so I'll just copy this. In the error, I'll just paste that value. It should be of the each error dot value should be of equals to, okay, so it should be of equals to the result and dot the error dot to string. Okay, so that should be fine, and I think that is the one we are loading, and false, it should be false, not the true. Here it should be also false, right? And then we have anything more, so I think I can remove this one for now, so I don't need it. So we just implemented that one using our Kotlin Flow over here. And then what we will do now is to go to update tags. So in the update tags, we have, I'll just create a new coroutine scope. So coroutine scope, and in this coroutine scope, I will call that particular function. So update tags. So this is the one, I think, right? Just copy this and paste it over here. And since this is the, and I'll just call the dot flow on, and the dispatcher dot the IO thread, and dot collect, and we have a result set return type, so it should be SQL to result. And then when we have a result, I can use of the when condition to check for the result over here, and then we will say that each result set dot the loading, if it is loading, and then I'll just copy this one for the other two, which is of the success now, and this should be of the error, err or error. Okay, so what we are doing over here is just the loading. So for the loading, I'll just copy from here. Loading is false over here, and here we need to make it false. Here we need to make it true. And then other thing is log. So just, okay, only the logs and the errors. Okay, so I just have to copy the same thing from here, the error message, and pass it before loading is cancelled. And then over here we are just logging to the logcat. So let us log it over here. I'll just say timber.d and the tag, we will get the result dot we get the data dot to string. So let's just log it only, right? We are not doing anything. Okay, so just cut this section, we don't need it. And Kotlin scope, why it's error. And okay, so error is, I think we haven't put this suspend function over here. So private suspend function of the update task. Okay, I think that should be the one that we are looking, and we can go back to our fragment for now. And in fragment, we have anything to modify. Let us take a look. I think we don't have to modify anything over here. We are just observing the live data, and I think that should be fine. So we are just when the button is clicked, we are updating the view model of the value for each variable that we have in the view model, and then we are calling that function edit task over here whenever the button is clicked. And okay, I think that should be fine. So we are just observing it, the live data, and that should be fine. So I'll just try to run my application. Let us wait for the application to come up. And the application is up, and let us try to amend this one. So test2 title. So what we will do is over here and try to amend this one or edit it. And I'll just say test2 title and great job, and just try to edit something, and I'll try to submit that one. Okay, successfully updated. Just okay, and now you can see that it has been updated with the edit that we made. And let us do for the same this one, edit it, and I'll just amend it to completed and comment it out as a great job. Okay, just try to edit it successful, and you can see that we have completed and as well as edited the body. So that's great. So we have successfully modified or edited our edit tags repository to make use of the Kotlin Flow as well as the view model to make use of the Kotlin Flow. And you can see the how code is organized, and it looks far better than the previous one. It's more readable. I think the code is more readable over here, right? And that's it. So if you were able to do it, that's great. And if you are not able to do it, just keep on practicing and just keep going. So just don't forget to practice. Just watching the video doesn't make any sense, and just try to practice. So when you practice it, you gain more ideas and how to do it, and you try to remember the logic and the process how to do all of this stuff, and you will get more familiar on it. So let's meet up in the next lecture. Till then, have a great day.